Hello, everyone. So it is 11 a.m. Let's get started. If by any chance you cannot hear me or you have any problems with the audio, then please comment in the box and I will try to change things. So hello, everyone, and welcome to this virtual neuroscience conference for teenagers. I am Sin. Give me 1 second. One second, I am currently having problems with my audio. One moment. That should be better now. I apologize if we have any technical difficulties. This is the first time that I am doing something like this technologically, so please bear with me for that. So once again, I am szintiaszert, the organizer of the conference. I am a junior in high school from Hungary, Europe, and I live in Austria. So I would like to thank everyone who is here right now and decided to come. To my knowledge, prior to this, there has never been a neuroscience conference for teenagers specifically before. So this is why I am very grateful for everyone who is interested in the event and came today. We have students here attending from the US, Europe, Asia, and even Africa. So I'm very happy about that. I find outreach programs like this really important to you as students, especially during this quarantine and pandemic situation. Right now, you have very few to no chances to get engaged in activities outside of school. So luckily, we could bring together this virtual event that nearly everyone can access. I believe it is also really important for you to access neuroscience information like this early on, in case you find that this is a career that you want to pursue and then do this in the long run. So in today's conference, we have well-known and respected professors who are going to be holding lectures for us today. So a huge thank you to all professors who are willing to present today and accepted my invitation. I am very grateful for your time. About today's schedule. So first we will hear the professor's lecture. Can everyone hear? There's a comment saying that you cannot hear me. Is it working fine? I think my audio should be working. If it's not working, then please tell me. Thank you. So about today's schedule. So we will first have the professor's lecture, and then we will have a few minutes for questions. So you can type your questions and comments into the comment box on YouTube. The recording of this lecture will be posted on YouTube at the end of this. So in case you missed parts of it, or if the stream gets blocked, you can rewatch it there. I will also be posting this on my blog, so you can look at it there as well. An important notice about the technological aspects. So you might have seen that I sent backup links in the emails that I sent out. We did have a few problems with the copyright behind this for some reason, and YouTube did block some practice streams. So in case this main stream gets blocked and gets taken down, then in the description below this video, you can click on the backup link, or you can access the backup link from the email that I sent. And then we will reconnect the conference on that stream. So once again, thank you so much for attending. So our first lecturer is Dr. Alan Francis from Harvard University. And his lecture is titled Impaired Decision-Making in Substance Use Disorders. So I'm going to bring in Dr. Francis now. Hello? I cannot hear you. You should have a button that you can click on to unmute.
Okay. Can you hear me now?
Yes, I hear you now. Perfect.
Excellent. Excellent. So thank you for that. One of the things um, one second. One of the things I have assumed when I made this lecture is that I assumed that the students have some amount of understanding of neuroscience, like for example, you know, neurotransmitters and action potentials, and how neurotransmitters are the basis of everything that we do. So on that basis, I have put in some information about neurotransmitters within this, and where possible, I will try to explain that. Okay, so I am going to now share my screen.
Yes, and I'm going to put you as the main viewer, and I'm going to mute myself. So thank you very much.
Sure. Okay, I'm trying to share my screen. Let's see. It's on. 1 second. Can you see it?
Yes, I see it. Yes.
Okay.
I'm going to check if it works on the stream as well. It should.
Okay. So from the beginning. Okay. One moment. I'm making it into the presentation mode. Yeah. Can you see it?
Yes, I see it. I think this should
Okay.
work on the stream as well. Thank you so much. Go ahead. Thank you.
Excellent. So I'm going to talk about decision-making impairments in substance use disorders. As you know, one of the most important features of why people get into substance use problems is because they have impairments in decision making, and we are going to try and look at the key factors that make up this whole decision making. And what I'm trying to do is, in this half an hour that I've been given, I'm trying to talk about both the neurocognitive aspects and neurochemical aspects of decision making. We'll first start off by looking at a particular case. We're going to look at a case of a 55-year-old male. Uh, Male. His vocation was a physician. He was from the Ivy League, and for those of you who don't know what the Ivy League is, some of the older universities in the U.S., including Harvard, Princeton, Yale, Columbia, all of them constituted what they call the Ivy League. It's because you had the ivy plant growing on these ancient structures. That's why it's called the Ivy League. But other than that, it's one of the older conglomerate of universities in the U.S. So this physician was a part of that. He was a person of high intelligence, and that's how he was able to get his medical degree and his practice. He was alcohol dependent, and he went through multiple treatments, and at the end of every treatment there was a relapse. He actually relapsed into heavy alcoholic drinking, and that had severe negative consequences that left him unemployed. So look at the picture. The picture is, you have a 55-year-old male physician from an Ivy League university of high intelligence, but basically what has happened is that alcohol has derailed him and he's unemployed right now. And again, I want to emphasize that there were repeated relapses, and he wants desperately to quit and focus on his life. Moving on, where in consultation with addiction psychiatrists, they found that he has a decision-making impairment. And this was not because he didn't have self-control or intelligence. This is because there were various factors involved in this whole decision-making impairment, and what those factors are, we will see as we move along. There was an initial use of uh, of substances, in early teen and while you're studying, there is always this exploratory phase where you explore. Why don't I try this? I try that. I try methamphetamine. I try cocaine. I try alcohol, and that actually led to an escalation of problems. And and by the time you actually realize, oh my God, I'm addicted to something, you can't leave it that easily, because what happens is, and when I was Cynthia's teacher in the Harvard Summer School, I actually told her, once your brain biology or the brain connectivity is changed, it's very hard to get back to where you were in the beginning. So this physician had these repeated relapses, and it was the decision-making impairment that actually led to these relapses. Okay, moving on. This lecture is going to cover the neurocognitive aspects of this decision-making impairment. We're also going to look at the neuroanatomical and neurochemical systems behind this decision-making problems. We're going to look at malfunction in substance use disorder. The last but not the least, we look at treatment implications, although I don't know if I have time to actually look at that. So I'm going to stop at the malfunction in substance use disorders, because I have, as I know, only 30 minutes to finish this talk. Moving on, we're going to look first at the neurocognitive aspects. How are decisions made? Let's go into the core of how decisions are made. Decisions are actually mental processes that have both neuro and cognitive aspects to it, and they involve three stages. They're interconnected and experience driven. It begins with stage one. As I mentioned earlier, there are three stages, and the first stage is stimulus valuation. Wait, one moment. Sorry. You evaluate a stimulus, and into this you have a choice of whether to go for it or not. Your disposition, I mean, whether you're whether you're in a happy frame of mind or you're sad frame of mind, you're frustrated, you've had a bad day, all of these are important factors that play into your choice of whether or not to consume alcohol. And the other thing that plays into it is salience. Its salience is generally defined as the importance. It's importance to you, and it's an introspective, how important is it to you type of a thing. And the whole situation, all of these four of them play into whether or not you would go ahead and consume alcohol. The second stage, the first stage, as I mentioned, is valuation. The second stage is implementation. Okay, so when you go into implementation, you actually tell yourself, you know what, I've had a bad day. I'm just going to go ahead and consume it, basically. And so you have an action selection there, and then you have an action performance. So you actually do that, and then you move into the third stage, which is you get the desired reward, which is called a wow factor. And as you can see, alcohol plays into regions in the brain that are called the ventral tegmental area, the nucleus accumbens, and the prefrontal cortex. I'm going to just show you alcohol plays into all of these key regions, which are rich in dopamine. And as I show you here, dopamine is very rich in these areas, and there is dopamine transmission across a tract called as the mesocortico limbic tract, which is the key tract in reward. Along with that, you have the neocortex, the hypothalamus, the locus coeruleus, the hippocampus, all of them sort of playing into this whole high or wow factor, if you may. So moving on. The fourth stage is when you get reinforced. So you begin with evaluation, and then you move on to implementation. And the third stage, as you know, is the outcome, which is the wow factor. And then you move on to assimilation of that information. You have knowledge, and this involves things like the hippocampus and the prefrontal cortex. And then you go back to this thing. So you tell yourself, okay, you know what? Alcohol is good. I feel good when I actually drink this. It takes me away from my problems. So then moving on, there are other things called as modifiers that are involved in it. And one of them is learning, which includes operant conditioning. You may have read in your psychology classes about Pavlov and his dogs. So that's exactly how it works here. So um, the stage one modifiers are whether you're hungry. It depends on your mood, um, your level of intoxication and withdrawal. All of these are key factors as to whether you would want to actually consume alcohol. And also behind that are traits which are inner cognitive processes like impulsivity. Impulsivity could be the reason why you actually, threw caution to the winds, if you may, and go ahead and just have alcohol or go to a pub and just drink. So impulsivity, and then emotion regulation to be able to handle your emotions. Like, you know what, I'm feeling down. I don't need this drink to make me feel better. You're able to emote, and that this aspect is a key factor in whether uh, you consume alcohol or not. A third thing is attention, and attention to the stimulus. I mean, studies have shown that people who are alcoholics have a greater, they pay greater attention to cues of alcohol or smoking or any other thing. And also inbuilt into that is, now that you have an understanding of what it can do to you, you have a craving to sort of have it again. And then one needs to think about the cost benefit analysis. And what happens in people who are alcoholic is their cost benefit analysis ability goes down a very great deal. They just are impulsive. They involve themselves in risky behaviors. Okay, moving on. So this is a stage called as the appraisal stage, where you appraise whether this is good for you or not. The stage two is modifiers. So the preference from stage one plays into other moderating cognitive processes or traits, such as such as flexibility, whether or not you're flexible enough to to change your mind, to stick with your desired plan to stop drinking. Whether you are whether whether you want to take the step saying, you know what, I'm not going to do this, or throw caution to the winds and then go ahead and actually do it. And into that also plays your level of inhibitory control. This is a key factor of behavioral inhibition, where you tell yourself, no, this is not for me. I don't want to go ahead and do this. And two aspects of cognition, namely selective attention and sustained attention, play into the whole inhibitory control thing. Okay, moving on. And this stage is called implementation, okay, where whether or not you're going to go ahead and just drink that. A third stage is called modifiers. Again, is a second modifier. And the action from stage two, the experience of the outcome, you know that drinking this amount of alcohol, may it be beer or vodka or any other, like brandy or whiskey, will give you the desired feeling of feeling good. The timing of the effect, and also the moderating cognitive process, such as value reward encoding, the ability to assess pros and cons, error calculation, and assimilation. All of these cognitive processes play an important role in whether or not someone makes a decision to consume alcohol. And what happens in people who have an alcohol problem is that all these cognitive processes have problems. They it's it sort of skews them from their goal of stopping alcohol consumption. Okay, so yeah, so moving on. In this case, in this case that we looked at, um, this person had in the stage one had difficulties at home and at work. He felt frustrated and stressed. So that actually led him or her, led him to actually consider alcohol. In stage two, he felt he was feeling very low, which means there was lower dopamine transmission. He was unable to fight his impulse, and so he went ahead and actually sort of consumed alcohol. And I'm just giving you a particular case of, when he would, um, one particular evening, what he would do. In the stage three, he goes ahead and consumes alcohol. He gets his pleasure and relief, and the drug use is reinforced. So in all of these stages, um, as I showed you earlier, there are several factors and several modifiers that in a sense sort of build up the whole um, um, decision-making process and how it is impaired in alcohol. Okay. Now that I've talked about the neurocognitive aspects, we move to the neuroanatomical and neurochemical systems. Okay. One of the most important neurotransmitter that is involved in the whole reward system is dopamine. And the dopamine is involved in the assessment stage by increasing salience and cost-benefit analysis. Um, what it should do is to tell you that alcohol is bad. The benefit of it is very low, but it doesn't because of the whole reward experience. You just go ahead and just consume this person just goes ahead and consumes the alcohol. The second stage is execution. Dopamine is involved in that. And dopamine is as I said in the class, is that it's a neurotransmitter of anticipation. You anticipate that you get a particular reward at the end of it. So it's involved in the action and also inhibitory control. But in this case, there's a failure of inhibitory control. And dopamine is also involved in the effect and learning. So you get the high and you get learning, which is in this case a maladaptive process. You adapt. It's you. It's something which you adapt to, but it's not really good for you. Okay. So moving on, the other neurotransmitter that is involved in this whole decision making stage is glutamate. And glutamate is involved in both the stimulus, which is the drink, and your preference for it. It's involved in the assessment stage. It's not involved so much in the execution stage, but definitely glutamate is involved in the learning stage. And again, you learn here a maladaptive behavior. Okay, you sort of learn what the cues are, and it's like an automated process. The moment you see the cue, you actually crave it. Okay. A third neurotransmitter is noradrenaline, which basically, in the body handles the stress response. That is, its main function is the sympathetic nervous system. You may have heard about the fight or flight impulse. So the sympathetic nervous system is a key factor in that, and also corticotropin releasing factor. It's also a key player in the CRF release. So noradrenaline is one of the neurotransmitters that's involved in the assessment of of um, of a drink. and it's also involved in the execution. I just want to go ahead and have it. And I'm sorry, it's also involved in the whole learning of, the ability to focus on the task, and also it's also involved in exploration, where you explore, if I have this ring, do I get the same amount of of a high, or if I have something else, do I actually get it? So this neurotransmitter, along with dopamine and glutamate, noradrenaline plays an important role in the whole decision making process. Okay, so in the brain, you have the regions, the activation of regions that are involved in decision making are, in stage one, that is assessment, you have the regions within the dorsal striatum, which, as you can see, is in yellow, and you have regions within with the ventral striatum also involved. As you can see, those those yellow regions, and this includes a region called the nucleus accumbens. In the dorsal striatum, it's more the caudate nucleus, the putamen, and the globus pallidus. And then you have the prefrontal cortex and the anterior cingulate cortex, which is right in the front of the brain. It's over here. The anterior cingulate cortex is over here, and regions of the prefrontal are here. And there are several subregions, including the orbital prefrontal cortex, the inferior middle, which includes the dorsolateral prefrontal cortex, and the superior prefrontal cortex. Okay, so in stage one, these four regions are involved. In stage two, the execution also the dorsal striatum and the prefrontal cortex, anterior cingulate cortex are involved. You have activation there. I have expanded it so what you can know what it's about. In stage three, the effect, that is the wow factor, you have both the ventral striatum and the prefrontal cortex involved. And when you learn it, the learned behavior, you have the ventral striatum and the prefrontal cortex. And here you also have the hippocampal region, sort of learning that whole experience. Okay, so moving on. There is dopamine transmission along the mesocortical limbic tract from the ventral tegmental area and the substantia nigra towards the striatum and the prefrontal cortex. There is another dopamine tract called the nigrostriatal dopamine, which is not involved in this. It's just mesocortical limbic dopamine. Okay. You have noradrenaline transmission between the locus coeruleus and the amygdala and the prefrontal cortex. Again, all of these neurotransmission is done in conjunction with a decision-making process. Okay, this is the neurobiology of decision-making. And you have the glutamatergic transmission from the prefrontal cortex to the striatum and amygdala. Okay, it begins with that. So it's in the opposite way. So when you have alcohol, or the whole decision-making process towards having alcohol, all of these neurotransmission happens. So we have looked at the neurocognitive aspects so far. We looked at neuroanatomical and neurochemical systems. Now we look at the malfunction in substance use disorder. So decision-making in substance use disorders happens because that is maladaptive decision-making in substance use disorders happens because of the failure of any three of the stages. The problems reflect biological changes, because once you have alcohol and you get the high, the biology of the brain changes. It's not the same brain that you're working with. And also you have possible premorbid deficits. In other words, the person who becomes an alcoholic may have prior impulsive behavior that contributes to kind of relapsing. So it's not just you took the alcohol and you became an impulsive person. You could have prior impulsive behaviors that led you to alcohol in the first place. And what happens is that This decision-making process is worsened by drug use. You have lower dopamine release for a given reward. You have lower receptor density. And as I taught in class, what happens is these receptors actually die out. I mean, they're no more expressed, because when you have a high, some of receptors, especially in the in the dopaminergic synapses, they actually are basically fried, so to speak. And you have an increase of noradrenaline and corticotropin releasing factor to stress, which again, when you release this onto the into the synapse, what happens is that they actually are bad for the synapse. They're actually neurotoxic. Okay, so in decision making, you have assessment deficits, which is shown as a greater response to a cue. You have a greater predilection to the cue. You have, as several cognitive tasks show, you have a greater preference for short-term rewards. Like, I want it now. I don't care about tomorrow or day after. I just want it now. So you have a shorter preference for the high, and into that plays the whole stress and also greater cue salience. For example, if you go and if you are trying to stop yourself from drinking, you should never go anywhere where drinks are being served, because those are all cues that actually draw you to actually repeat maladaptive behaviors. Okay. Also, you have execution deficits. People who have decision making problems have execution deficits. Um, they prefer habitual actions. What they did before, they just want to do it again. I come back home from work, I've had a stressful day, I'm going to have a drink. You know, they just can't see other options, because in habit change, there needs to be a change in, you know, in in certain behaviors that veer you away from your original, behaviors that led you to alcoholism. There's a lower degree of inhibitory control, and you just can't hold back. Okay. In maladaptive decision making, a third problem is you have deficits in learning and effect. What happens is, over time you have an imbalanced reward encoding. The first drug use gives you a high amount of reward because your brain is naive to the drug. The moment you have experienced that high, once you do that, the very next time, once dependent, there's a lower drug reward. And you need to have more of it in order to get the same amount of high. This is a phenomenon called tolerance that you will learn as you go on. And you don't learn from the negative aspects of it. You just don't think, I got to change my behavior because this is not serving me well. I need to, stop all these. I need to stop these habits. That aspect is not there. Okay. And to sum this whole case study, there was problems with assessment. There is a greater preference for the drug. There were problems with execution. There was lower inhibitory control. There was a problem with the effect. There was a greater high when the person consumed it first, and then a lower high once you kept consuming it over and over again. Okay, and the fourth one is they don't learn. That is, there's a lower learning response to the whole negative consequences of drug addiction. So because I've run out of time, I'm going to stop there and say thank you for this opportunity. I thank Cynthia, who was my student in the Harvard Summer School. It is really wonderful that you've done this entire thing. I hope this was helpful. Thank you.
Thank you, Dr. Francis. Thank you so much. It was really interesting. We have a question here from the comment section. So someone was asking about what CRF stands for. Someone answered that, and you also said that it's the corticotropin release factor.
Yes.
Could you shortly describe what exactly?
Okay. Okay, corticotropin releasing factor is a stress hormone. When a person is under stress, as as I told you that you have this flight or fight response. So in order to protect our bodily systems, corticotropin releasing factor is released into the HPA, the hypothalamus pituitary axis, and that actually releases adrenaline or epinephrine that actually helps you handle the immediate acute stress. So what happens when you take alcohol is it imitates that. It imitates that, and the alcohol um, sort of the need to consume alcohol increases, and there is a lot of stress that leads you to actually take it. And so am I making sense to you?
Yes, thank you so much for that explanation. So there's another question. The question says, how can mindfulness meditation reduce or help reduce relapses, like in
Okay.
addicts?
Okay. um, Mindfulness is an excellent way of of changing maladaptive behaviors, because mindfulness and meditation helps you to look at your problem from a you know from not a personal view, but from a you sort of disembody the problem that is happening and look at it, and tell yourself, um, why is this happening to me? Why is maladaptive decision making happening? How can I change it? Taking part in meditation um, sort of helps you in changing patterns of behavior that would normally lead you to consume more and more of alcohol. It 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 definitely helps.
Great, thank you so much. And so the next question says, if you can suggest any sources for reading about this topic, any specific books that you would recommend?
Okay. One of the best books, I have it right here, is by Dr. Mark Shuckett. Mark Shuckett. It's an excellent book called Drug and Alcohol Abuse. This is a beautiful book in that Dr. Shuckett goes into the core of alcohol abuse, and he looks at it from several um, from several aspects of it. So it's both for clinicians as well as for people who are interested in changing alcoholic behaviors. And yeah, this is an excellent book. Um, I think there is a paperback version of this. Yeah, I hope that helps. Also, there's also one more book I have it here, right here. It's called Educating Yourself About Alcohol and Drugs. This is fairly cheap actually. This shouldn't be more than say 5-10 bucks. And Dr. Shokit is a friend of mine. He's one of the most eminent alcohol psychiatrists. He's a distinguished professor of psychiatry at the University of California at San Diego. This book is excellent, if you ask me. Okay.
Yes, thank you so much. And there's one last question that says, have you had any experience with any substances yourself?
Um, the honest truth is no, but I had my father. My father was a he smoked he smoked nicotine. He smoked nicotine for like several years, for nearly 40 years. And he started when people didn't know that nicotine was something bad. He, he and his friends used to smoke a lot. And by the time he realized that nicotine is something terrible, and it can fill your lungs with tar, and tar it's very carcinogenic. But by the time he actually understood that, it was too late for him to actually make any dramatic change. And he actually passed away because of a nicotine-related heart problem. So yeah, that's the closest I've gotten to a member of my own family suffering from problems with addiction.
Yeah, I'm sorry to hear that. Thank you so much. We actually have a few more questions here in the last minute. Could you please type the name of the author into the chat here for me, and then I'll post that in the YouTube comment, because
Okay.
someone was asking for the exact author name.
Okay, let me just do that.
Thank
Chat.
you.
The author's name is Shukit, Dr. Mark Shukit. Drug abuse.
Yep, thank you very much. I will post that into the comment section in one moment. And so someone asked, how is alcoholic addiction different from other addictions which do not interfere with the biological matter of the brain?
All addictions have a neurobiological component. When you say addiction, the word addiction is defined by the National Institute of Drug Abuse as a neurobiological problem. I don't want to go into the actual definition because it's very, very big, but it's called an addiction and not a habit because of the fact that there is a neurobiological change. And basically, it's an almost permanent change. It's when I say almost permanent because into the change, depending on how old you are, and how it, these are neuroplastic changes that are bad for you. I mean, as you know, when you're young, your brain is very adaptive. It's very neuroplastic. These are, I mean, what happens is with alcohol and other drugs is that this plastic brain is sort of molded into a particular direction from which there is almost no comeback. You have to you have to go into a lot of therapeutic interventions, including cognitive behavioral therapy on the one hand, and then because to change your strategies, and then look at alternative you know um, methods to try and wean you away from those drugs um, the, because it's a severe problem because of the fact that it changes a person's brain. It changes the way dopamine it's transmitted, and various other neurotransmitters are transmitted.
Great, thank you very much. And so someone asked, can alcoholism be reversed? So I guess that really depends.
Yes, you can. I mean, alcoholism is a big, major global problem, and it has affected many families. Because people don't are not able to control beyond a certain stage. The answer is yes, but it not only involves um, a personal dedication towards change. It also involves the whole family. That is, you need a whole society to help you out in this entire thing. In my experience, I've had colleagues who've been who have been alcohol addicts. There's a friend of mine from Russia. He was addicted to a lot of vodka. He just doesn't take any more alcohol ever. Whenever we go out for a drink, probably beer or so, he would never touch that. He would always have tea. And so it's a personal commitment to change, but it's also the whole society and also cognitive behavioral therapy, which actually helps a person stop maladaptive behaviors.
Great, thank you. And we have last two questions. So for alcohol addiction, can it be genetic? So when pregnant mothers consume alcohol, it negatively affects their child. And so how exactly will it affect their child?
The The short answer is yes. If you consume alcohol when you're expecting a baby, it depends on which trimester you've been having. If you've been having throughout the entire pregnancy, it definitely affects the offspring. But it could affect the offspring in several ways. It again depends on the level of consumption. One is they are cognitively impaired. They experience learning deficits in school. They're not able to keep up with other students. They also uh, they also are sort of predisposed to addictive behaviors. Okay, so yeah, I would like to stop this answer with that. I don't want to go further on that.
Great. Thank you so much. Yeah. Thank you. I think that's it for questions. Thank you so much for your lecture. I really enjoyed it. Thank you so much for
Thank you,
attending.
Cynthia. Thank you for the opportunity.
Yeah, thank you very much. So we will move on. I will put you as an attendee. So our next lecturer is Professor Amy Arnston from Yale University, and her lecture title is The Brain's Response to Stress, How Our Brains May Be Altered During the COVID-19 Pandemic. So yes, hello.
Hi there, can you hear me?
Yes, I can hear you. Perfect, thank you so much.
Let's see if we know. How's that?
Yes, that looks perfect. Thank you so much.
Thank you so much, and hello to everybody. I'm going to be talking about what our brains are going through as we go through this global pandemic, and helping us understand why we're feeling so differently, thinking so differently than we usually do. I want to say that this talk is based on a video I made that's at the Yale Medical School YouTube site. And in this one, it has a musical background rather than me talking, and I've just got to do a plug here. The musical background is by my son's progressive rock band, the song Skyline. So how can I resist telling teens around the world about his music? So there, I'm shameless right off the bat. So what we're going to do today is first talk about the different parts of the brain. First, the more primitive brain regions that perform very basic functions and, very importantly for today, generate a lot of our emotional responses. And then we're going to talk about the newly evolved brain regions that generate higher cognition and top-down control. Specifically, we're going to focus on something called the prefrontal cortex. And then we're going to talk about how the arousal systems have huge effects on these different brain pathways, how they orchestrate which brain circuits are actually in control of our thoughts, our actions, and our emotions, and how the arousal systems can switch us to a very primitive brain state when we feel stressed and out of control. So let's start by some of these more primitive brain circuits. And some of this you'll have just heard from Dr. Francis, some of these same brain regions that he mentioned. So some of these regions are those that generate our automatic unconscious responses, such as controlling our heart rate and breathing and our emotions. A lot of this being done by the brainstem, going down to our viscera. And the amygdala is one of the most important of these primitive systems because it controls and orchestrates many of our emotional responses, including the fear response. So, for example, it's activated by the sight of a snake or a tiger, but especially important even by objects that remind us of where we last saw that snake, like when we come to the turn in a certain favorite hike. Oh, that's where the snake was. We remember that. And that's because of the amygdala. And we'll be hearing more about that, I'm guessing, from Jim McGaw later this afternoon. So the amygdala has extensive connections and is able to activate lower brain circuits, and that can make us feel anxious and sometimes even fearful, depending on what's happening. Another important structure that we just heard about from Dr. Francis is the striatum, the dorsal and ventral parts of it. And the striatum mediates many of our habits, including habits we acquired as children, like walking and reading, so motor and cognitive habits, but also more recent habits, like what to do in an emergency. For example, around here at least, we're in the habit of buying bottled water during an emergency. But during COVID, buying bottled water is really not helpful. Our water supply is fine, but nonetheless, water was sold out when I went to the supermarket that last time. So these habits that we do automatically are carried out by the striatum, including emotional habits. The ventral striatum that we heard about last time, that is, for example, the reward signal. Then we have the hypothalamus, which is at the base of and center of the brain, and it mediates many of our biological drives, such as thirst, hunger, whether we feel hot or cold, and even aggression. And the hypothalamus has connections to activate our sympathetic nervous system, to increase our heart rate and breathing, to activate adrenaline release from the adrenal medulla, which we heard about in the last lecture. And the hypothalamus also controls secretions from the pituitary gland, which hangs right off of it. And it releases something called ACTH into the blood to activate cortisol release from the adrenal cortex. And this is what we were learning about also in the last lecture. And altogether, this is called the HPA axis, hypothalamus pituitary adrenal gland. And then cortisol is released from the adrenal cortex, and it travels through the bloodstream to coordinate both the body and brain's response to stress. For example, increasing glucose availability, increased breathing. And it can also strengthen the functioning of primitive brain systems like the amygdala. But as we'll see, it can weaken higher brain functions. And later in this video, we're going to see that the brain's own arousal systems can also strengthen primitive brain circuits while weakening the higher brain functions during stress. And that's going to be our major focus in a little bit. But first, let's learn about those higher brain systems. And this is learning about our cortex. Cortex means rind, and it is the outer covering of the human brain and is vast in human primates. So here we get to see the primary sensory and motor cortices. So motor, somatosensory, visual. And the primary sensory and motor cortices are doing these very simple functions of processing incoming sensory events, such as for vision, touch, and hearing we have here. And the motor cortex initiates motor responses by projecting down to the spinal cord, where it gives orders to control our muscles. But beyond that, we have very high order brain systems in our cortex. And today we're going to focus on the prefrontal cortex, because this carries out our very highest order cognitive abilities. It is what's responsible for higher reasoning and abstract thought, working memory, our mental sketch pad, and our ability to focus on things that are relevant, inhibiting inappropriate impulses and habits. We were hearing a lot about this in the last lecture. Planning and organization, planning for the short-term future, but also the far-term future and how we actually get there effectively. Flexible decision-making, and this was a lot of the last lecture, making decisions that actually help us in the long run and that can change based on changes in the environment. So we're always doing what's best for us. Empathy and moral conscious, really being able to understand what others are thinking, feeling, and needing, and doing what's right. Having patience and hope. The prefrontal cortex is really a mental cheerleader. And metacognition, thinking about thinking. insight about ourselves and other, and judgment about our own actions. Are we thinking, doing what's right? So in general, the prefrontal cortex is carrying out what we call thoughtful top-down control of emotion, thought, and action. And it does it through these extensive connections throughout the brain. And there are several examples here of how important the prefrontal cortex is for thoughtful top-down control during this pandemic. This COVID-19 emergency is different. I need to buy Tylenol, not bottled water. I shouldn't touch that box of cereal yet. It looks normal, but it may be contaminated, so impulse control. I had been looking forward to this reunion trip to Colorado for 3 years, but even though I'm young and healthy, my traveling right now could really endanger people who are more vulnerable than I am. I am so bored from being socially isolated all these weeks, but I should not go to that party at the beach because I may get infected and not even know it. So these are the kinds of thoughts that prefrontal lets us have. And we can see how these prefrontal operations are involved. So abstract reasoning, being able to see the invisible, incredibly important right now with this pandemic. Being able to sustain our attention and focus and maintain goals despite distractions, including distractions from social media. Patience and impulse control, inhibiting prepotent but now inappropriate habits like reaching out to handle your groceries or to hug somebody, the desire to be with friends. Being able to plan ahead, really important that you plan your current actions, not going out, to enhance well-being in the future so you or somebody else won't die. It's really important, and yet it's so abstract. Empathy, caring about others and not just yourself. So even if you don't get sick, somebody else might get very sick. And this is a sign of personal maturity, and really it's a sign of a civilized society. So arousal state has huge effects on brain function, and it's why these prefrontal top-down functions can be so hard to maintain under conditions of fatigue and or especially uncontrollable stress like we're all going through now. So different levels of the arousal chemicals are released in our brain based on whether we are asleep and fatigued, alert and interested, or stressed and feeling out of control. And these arousal systems project usually from the brainstem, sometimes from the base of the brain, and go out and spread through most of the brain. And we're going to be focusing on norepinephrine and dopamine, which we heard about in the last lecture, but they also involve things like acetylcholine and serotonin, which we will not talk about today. So there are low levels of arousal chemicals released in our brain when we're asleep or very tired and fatigued. And this is an inadequate chemical state for much of the brain to work effectively. And including for prefrontal cortex, it weakens prefrontal connections. And this can impair cognition and top-down control. When we're alert, safe, and interested, we have moderate levels of arousal chemicals released, and we get an extra little pulse to salient relevant stimuli. And these are ideal for strengthening prefrontal connections and having us have strong cognition and strong top-down control. But when we feel stressed, and especially it has to be uncontrollable stress. If it's a stressor where we feel, oh, we got this, we're confident, these chemical responses don't happen. But when we feel out of control, we have high levels of arousal chemicals released in the brain, and especially in the prefrontal cortex. And this rapidly shuts off prefrontal cortical function. It impairs our top-down control and can make us distracted, forgetful, disorganized, less thoughtful and more reactive, more emotional, irritable and impatient, and rigid and more concrete. So we can be inflexible in our decision-making and also not be able to evaluate information as well. So we can be more vulnerable to scams. And we've now learned a whole lot about the cellular basis of this. This is what my lab studies. And we actually now know what happens to cause the stress-induced prefrontal dysfunction down at the level of ion channels. So I'll give you a very brief review of that, where what we have learned is the ability to keep information in mind, to have abstract thoughts, is due to pyramidal cells, they're shaped like pyramids in prefrontal cortex, that all have the same shared characteristics. So let's say they're all trying to represent a position in space, 90 degrees. And so what they do is they all excite each other through glutamate synapses to keep us thinking about that position in visual space, even without any sensory stimulation. And so this is the basis for abstract thought, that the brain itself can generate this excitation without needing a sensory stimulus. And these synapses where this excitation occurs, or it's glutamate release onto synapses on spines that contain NMDA receptors. And here's a cartoon of this close up. So here's neuron 1 exciting neuron 2 through glutamate release onto NMDA receptors. And if there's enough of this, the signal gets all the way over to the dendrite of neuron 2 and sends that down to the cell body. If there's enough of it, it can then send out an excitatory signal to another neuron and even back to neuron 1 to keep that going. What we've learned is on these dendritic spines where these synapses are, there are also these potassium channels. And under normal conditions with no stress, these channels are mostly closed. And so the signal gets across and neuron 1 can excite neuron 2 through a strong connection. But with stress, when we feel out of control, there are very high levels of norepinephrine and dopamine release in prefrontal cortex that excite stress signaling pathways inside the spine, which then open these potassium channels. And that disconnects the input so that this excitatory signal basically leaks out the potassium channels, is one way of thinking of it. And so neuron 1 can no longer excite neuron 2, and it's disconnected. I wanted to point out, just so nobody's confused, we heard in the last talk about both norepinephrine and dopamine. I think Alan called it noradrenaline, very British. Dopamine in the ventral striatum is rewarding. And so we heard a lot about that. However, the dopamine cells that project to the prefrontal cortex are completely different from the ones going to ventral striatum, and they give what's called a salient signal. They will fire to rewarding events, but they also will fire a whole lot to an aversive event. And so we get high levels of dopamine release in prefrontal cortex during threat and uncontrollable stress. We don't get it in the ventral striatum with threat. In fact, dopamine then goes down. So just in case that was confusing anybody. But what we have here is high levels then of these arousal chemicals, norepinephrine and dopamine, magic done inside the cell, which we have been studying, which leads to the opening of these potassium channels and disconnection. And this can happen very rapidly, like if you're cut off on the highway while driving, prefrontal rapidly going offline. And that's helpful on the highway, but not if you're trying to deal with an invisible threat. And with chronic stress, this sustained weakening of these connections actually leads to loss of the spines, loss of the connection, what we call atrophy. And you can have even more dramatic loss of prefrontal functions and more vulnerable to depression, losing perspective, and feeling despair. The other thing that happens with uncontrollable stress is we have a double whammy. We actually strengthen our primitive connections. So the same chemicals, high levels of norepinephrine in particular, that take prefrontal offline strengthen the amygdala. And we're probably going to hear about that from Dr. McGaw this afternoon. Oops. Why you can have a flashbulb memory of something like 9/11, because we'll hear from him, I think, how amygdala then says this, we should consolidate a long-term memory of this event. It is very important. So at the same time, prefrontal is impairing your abstract reasoning, your working memory, your mental sketchpad, making you distracted. The amygdala says, but we're going to remember this event because it was terrible. And with chronic stress, the connections in the amygdala actually expand. So a true double whammy. These are getting bigger. We're losing these connections. And so this can make us feel more anxious and react less thoughtfully as we switch over to this more primitive state. And so a summary of how arousal state influences our brain state. We go from high order circuits making us thoughtful and reflective when we feel alert, safe, and interested, to the more primitive circuits being in charge of our behavior and thoughts and emotions under uncontrollable stress, switching us from reflective to reflexive and reactive. And so it's amazing that just the amount of norepinephrine, for example, can switch us from this to this. So here are some examples of what we're like during COVID due to having weaker prefrontal function. We can have impaired abstract reasoning, less ability to plan ahead. So we put ourselves and others in danger by not seeing an invisible virus and its possible consequences down the road. Being more forgetful, distracted, and disorganized. A lot of us are having a hard time concentrating or finishing things. I even have a hard time finishing things on Netflix. Harder to sustain attention on an assignment, being more easily distracted, for example, by social media, becoming impatient and irritable, which, like yelling at my husband, not a good thing to do when you're stuck in close quarters with the same people for a long time. And having worse top-down control in cognitive, motor, and emotional domains. So choosing to go out when you know you should stay home, touching things that could be contaminated, getting too close to people, especially when you're used to physically being close to them, saying hurtful things to loved ones. And as we just heard about substance abuse, when you have weaker prefrontal function, you have less ability to inhibit reaching for the alcohol, the cigarette, unhealthy foods. So very much what we were hearing about last time related to this weaker top-down control and stronger habitual responses with uncontrollable stress. But thankfully, there is indeed resilience. Prefrontal connections can regrow with a sustained period of non-stress. And it can also be diminished if we can feel in control of the stressor. Now, that's really hard to do with an unknown virus, and especially when it feels like the government is not dealing with it effectively. But we can try and do small things within our own lives to help our own brains feel better. Deep breathing actually normalizes the arousal system, so that can be helpful. Exercise can actually strengthen prefrontal. And mindfulness, mentioned last time, also strengthens prefrontal. Keeping informed, but not watching the news obsessively, especially when it's really about raising emotion. Creating a new realistic schedule for yourself for work at home, and really succeeding with small realistic projects so you have a sense of accomplishment. Talking with friends where you feel a support system, and experiencing beauty and humor that can help with our perspective on things. And helping others is just tremendously important for even helping ourselves. So remember that if you are feeling distracted, forgetful, going in circles, don't blame yourself. This is a natural brain response to uncontrollable stress, and compassion for ourselves and others helps us all. So if you're interested, we wrote a review for the lay public on the relationship of stress, prefrontal, and substance abuse in this Scientific American. If you're wanting to tackle something a little bit higher order neuroscience, I wrote this review in Nature Reviews Neuroscience that you might be interested in. In general, there's information on neuroscience at the Brain Facts website at the Society for Neuroscience. So I would point you towards that if you were interested. And thanks to Cynthia she's just remarkable. I think she has a fantastic prefrontal cortex to have created this today. So thanks to her. And questions?
Thank you so much, Professor Arnson. Thank you so much. I think this lecture relates so well to what is going on right now. So that is perfect. So for questions, so the first question says, what does the level of norepinephrine and dopamine have to do with the potassium channels? Does it have to do with the membrane potentials and the charges of the neurotransmitters?
I of course didn't go into much detail on this, but I can't resist with such a question. So what these potassium channels are opened by something called cyclic AMP, something called protein kinase A, which is activated by cyclic AMP, and they can also be opened by calcium. So there's a whole variety of potassium channels, and each is opened by a different thing. High levels of norepinephrine and dopamine can increase calcium, increase cyclic AMP, and increase protein kinase A. That's what this is. And the net effect of that is to very rapidly open these potassium channels. What happens at the ionic level then is when the potassium rushes out, the spine becomes what we call hyperpolarized. And so that means it's less likely that this neuron will be able to fire an action potential. This excitation coming here from the glutamate interaction with the NMDA receptors is depolarizing, but if it then encounters a hyperpolarized space, these two cancel each other out. So I'm guessing for some of you that's too much information, but I'm hoping it answered it for the person who asked the question.
Great, thank you so much. And so someone asked, are we stressed because we are forced out of our control zone, usual habits, or because we sense this situation as danger?
I think it's both, and that one reinforces the other. I mean, we certainly know that it can be dangerous because we've gotten to hear how so many people are dying. We get to see images inside of hospitals that are really scary. Some of us know someone who's gotten very ill or even died. So we have the information that this virus can really be dangerous, including to young people who have sometimes strokes. So even if you don't die, you might be permanently disabled. Or if you are carrying the virus and don't even know it, killing someone you love, and how terrible that would feel. We have that information, but then also being in this strange reality reinforces things are not normal. And things like going to the grocery store and not being able to get the things you need, for me at least, that really made it scarier. At first I thought I wouldn't be able to get medications. You know, we had no idea what was going to happen, and that uncertainty made it even more frightening. And then when we realized that many of our leaders weren't able to do things to help either, that there's not enough PPE, for example, feeling the disorganization and knowing that other people were not in control of the situation either, that I think really has increased the fear of everyone.
Thank you. And how do we strengthen the prefrontal cortex?
So I had that, let's see if I can find that one. So deep breathing, actually, there's centers in the brainstem that then project to the neurons that make norepinephrine and slow their firing so they don't release too much norepinephrine in prefrontal. So just that kind of deep breathing, something people have known for thousands of years. That's probably part of the neurobiology. Mindfulness and meditation are known to strengthen prefrontal, and exercise can strengthen prefrontal. And we have some unpublished data that the lactate acid that's released by your muscles might actually help to strengthen prefrontal connections and reduce the stress response. And then I think doing whatever you can to help make yourself feel more in control in a positive way, and giving yourself sense of accomplishment and, if you can, safety. That those things will also help reduce the stress response and help prefrontal be stronger.
Great, thank you so much. And so does a reduction in connectivity mean a reduction in white matter?
Wonderful question. Ultimately, that can be true. So if you end up actually losing a neuron, the whole cell body, and its axon, which then is covered with myelin, which is the white matter. But usually with these things, we're just losing the spine, the synapse connection, and the cell body is still there, and the white matter is still there. So the what's called gray matter is much more vulnerable, but luckily also much more plastic. So most of this is seen, at least initially, just in the connections between cells, which can go away and then come back. And the white matter stays quite intact.
Great, thank you. And so why do some people seem to cope better with stress than others, especially during this time? Is there a connection to brain function?
Yes, there's many reasons. One could be that they have experience dealing with stressors and have more confidence. I've been through something like this before, and I know I'll be okay. Some of it can be neurobiological, such as if you were exposed to stressors as a child, trauma, for example, where you now have lost prefrontal connections as a child, and you see, the data suggest you have a lower threshold than for responding again as an adult. So the stress response is primed if you've had a traumatic childhood. So that's both psychological and neurobiological. And then things such as genotype, it's known, so there's an enzyme called COMT, which chews up dopamine and norepinephrine. And there's a variant of this, which is weaker, so it's not as good at chewing up norepinephrine and dopamine. And people who have that weaker type of enzyme are more prone to having a stress response and have prefrontal dysfunction during stress. On the other hand, they're often better at cognition under non-stress conditions. So there are probably many more genetic changes like that that have subtle but meaningful effects, but that's one that's been clearly seen.
Thank you. And how long would it take for the mind to recover from this event? So from like the pandemic?
So we don't know for sure. Studies in rats have shown that what they did was the same length of time that the rats were stressed. If they have that same period of time now non-stressed, the connections have regrown. But I think it's really going to be a complex factor of what other stressors you've had in your life before then, genetic factors, as we've said, how severe the stress is, how young you are. So you guys are more plastic than I am. So for me, it would take me probably longer to have my connections restore. On the other hand, I might have experienced other things like this where I'm not feeling as frightened as you are, because I've been through something like this and survived. So very complex set of factors that all come together.
Thank you. And last two questions. So do you have any resources about breathing exercises and the effect on the brain?
Oh, I'd have to look that. It's a wonderful paper that came out, I think it was last year. And I'd have to look it up later, and maybe I can send it to you.
Yes, perfect. Thank you. Yeah. And the last question, does sleep impact stress levels?
Absolutely. Because if you don't get enough sleep and you're tired, your prefrontal is already weaker, and then you add the stress, and you're much more rapidly vulnerable. This is the situation we can get, for example, in burnout, where healthcare workers are both exhausted and fatigued from not having enough sleep, but also stressed by the terrible things they're having to deal with. So a good night's sleep, if you can get it, is wonderful and protective.
Great. Thank you so much. Yeah,
My
thank you
pleasure.
so much for the lecture.
Thank
It was
you.
really interesting. Thank you so much. So we will continue then with our next lecturer. So our next lecturer, if 1 second. So the next lecturer is Professor Alexandra Basilakos, and her talk is about language and the brain using neuroimaging to understand aphasia. 1 second. I think you are muted. 1 second.
Can you hear me?
Yes, I hear you now. Yeah.
Perfect.
Thank you so much.
Thank you. Thank you for organizing this, and thank you for all tuning in. My talk will focus on language in the brain. So I'll focus on using neuroimaging to understand aphasia. I am both a researcher and a speech-language pathologist, and some of you may be familiar with speech-language therapy. Speech-language pathologists, or SLPs, treat speech, language, cognitive, and swallowing disorders that may occur across the lifespan. My particular research interest is in brain-based communication disorders, specifically those caused by stroke. And I think most importantly, as Dr. Arnsten stated at the end of her lecture, is that COVID has been associated with an increased risk of stroke. So I think it's really important to talk about some of the effects of a stroke, what are the signs of a stroke, and one specific after effect of stroke called aphasia. So my research uses neuroimaging methods, principles of neuroscience, and brain plasticity, and applies these theories to treatment of communication disorders that can occur because of a stroke. So essentially, my work is really an application of a clinical application of neuroscience. So I'll focus this lecture as just discussing what is stroke and what is aphasia, what parts of the brain are involved in language and aphasia, and then how neuroimaging can help us understand and treat aphasia. And I've got one case study that I'll talk about throughout this lecture. So let's focus on what a stroke is. So essentially, a stroke is a loss of blood to a part of the brain, and there are two different categories. They can be hemorrhagic, which is an arterial burst, or ischemic, which is an arterial occlusion. So I'll explain that a little bit more on the next slide. With an occlusion, this is the ischemic stroke. This is the most common type of stroke. An occlusion can be caused by arteriosclerosis, or when plaques within an artery build up and block blood flow. It could also occur because a blood clot travels from one part of the body and lodges in an area near the brain, then blocking blood flow to the brain. So with COVID, what's happening is it's thought that it changes clotting factors within the blood, which could actually lead to that increased risk of stroke. An arterial burst or hemorrhagic stroke can occur when a weakened blood vessel bursts and bleeds into the surrounding areas. Some warning signs of a stroke that are really important to know if you are experiencing these or somebody around you is the acronym Be Fast. So individuals, when they begin having a stroke, may notice that their balance is off. They might notice sudden dizziness or being uncoordinated. There might be difficulty seeing, so suddenly blurry vision or double vision. They might notice drooping of the face. So this usually happens on one side of the face. It can affect the musculature that innervates the face, so causing that drooping. Individuals may have difficulty raising their arms. So if you notice somebody having these symptoms and you ask them to raise both of their arms, they have difficulty raising one of those arms. That might be a sign that they're having a stroke. I should also notice that sometimes people have difficulty also moving their legs. So let's not forget that both limbs, upper and lower, could be affected. One of the first warning signs of stroke is often a change in speech, so slurred speech. This could be most likely due to the fact that the facial muscles are affected. But with T, the last part of that BFAST acronym is time. So make sure to call 911. And I know some of you are in different countries, so the emergency line in your country, so that you can get the individual that's experiencing stroke symptoms help quickly. There are treatments that can be done to limit the effects of the stroke on the brain. These might be clot busting treatments. So if there is a blood clot, kind of releasing that clot to allow blood flow back into the brain. If an individual is having a bleed, it might be having to evacuate the blood from the brain, or in the case of an aneurysm that has burst, coiling or clipping that aneurysm to reduce the bleeding on the blood. I do also want to point out that a sudden and very severe headache, for example, the worst ever had, may be a sign of hemorrhage. So understanding these signs and symptoms of stroke are very important, especially in the United States. The risk of stroke is one of the leading causes of adult disability and a leading cause of death. My lecture will focus specifically on communication disorders that result from a stroke. Your brain has three main arteries: the anterior cerebral artery, which you see here in yellow, the posterior cerebral artery here in blue, and the middle cerebral artery, which is this territory in red. The areas in red are all areas that contribute to language function. So a stroke to these areas can cause aphasia. And I'll talk about what aphasia is in the next few slides. So just to take a step back, stroke is a major public health concern, and this was true even prior to COVID. It is the fifth leading cause of death in the United States, and as I mentioned before, it is a leading cause of disability. Let's just talk about some of the associated deficits. These might be communication impairments, which I'll focus on today, including speech and language disorders. Individuals may experience limb paralysis or paresis, so weakness in the upper or lower limbs, the arms and legs, or inability to move. Individuals may experience memory difficulties, changes in vision, and most importantly, in cases of stroke that result in chronic deficits, individuals may have a loss of independence or a decreased quality of life. Individuals may not be able to return to pre-morbid vocational or recreational activities, meaning that their disability after the stroke, for example, let's think of a communication impairment. If you're unable to communicate with those around you, this would absolutely affect your ability to engage with family, friends, and loved ones, and also affect your ability to go back to work. So it's not surprising that aphasia and language, or as I'll talk about when we talk about language disorders, but aphasia and stroke can also be highly associated with a decreased quality of life. So now getting into aphasia. As I mentioned, aphasia is a communication disorder that results from stroke. So let's talk about what it is. It's a disorder of language. It can affect speaking, so things like finding the right words to say. Individuals with aphasia often have what we call anomia, which means they're unable to find the names of different words. They might also have difficulties with syntax, so combining words together to form sentences, and grammatical structures. Individuals often report difficulty reading, and this is not due to the vision loss, or if there is vision loss associated with the stroke, it's the ability to actually, for the brain to process written language. Individuals may also have trouble writing and listening or comprehension. So actually, when you tell somebody something, having difficulty processing that message to be able to understand spoken language. And of course, these symptoms can vary based on the individual, could be different based on the lesion size, so the size of the stroke, or the amount of brain that's affected. Aphasia is most commonly caused by a left hemisphere stroke, and left hemisphere stroke is the most common cause. Some studies have shown up to 50% of individuals have aphasia at acute stroke onset, so right after the stroke happens. And then it's been suggested that about 30% of individuals go on to have long-term lasting deficits. Aphasia can also be caused by a tumor, brain injury, or multiple sclerosis. And it may resolve. So for some people, they may have difficulties with communication right after their stroke, and this may go away in a couple of months. But for other individuals, this could be a chronic and lifelong condition. Approximately 2 million people are living with aphasia in the United States today. I do want to point out that aphasia is not a disorder of intellect. So just because somebody has difficulty communicating does not mean that the stroke has affected their intelligence. It is not the communication problems are not caused by hearing loss. So an individual who has difficulty understanding language, it's not because they can't hear, it's because they have difficulty actually processing the language in those language centers in their brain. Individuals with difficulty speaking, that difficulty is not due to paralysis or paresis of the facial muscles. It should be noted that these impairments can co-occur in aphasia, but they are not the cause of aphasia. So I want to show you an example of an individual who has chronic Broca's aphasia, very severe aphasia. This is, if you're interested in the topic of aphasia, I do want to point out a lecture by Dr. Julius Fredrickson. He's the principal investigator at the Center for the Study of Aphasia Recovery, where I do my research. And I'll talk about a treatment called speech entrainment that he focuses on a lot in that lecture. So if you're interested, that's the title of his lecture. But I want to show you an individual who is 22 years post-stroke, and he has non-fluent Broca's aphasia. So with Broca's aphasia, and I won't have time to get into the different types of aphasia today, individuals often have spared comprehension, so their ability to understand when people are talking to them is relatively intact, meaning it's a strength for them, but they have difficulty producing language. So phrases are very short. They might only be able to get out a couple of words at a time. So I'll go ahead and play this. And I'll talk about the audiovisual feedback that it mentions at the beginning of that clip later. So this will be our case study for the rest of the lecture.
Try to say you can about eggs.
Eggs. Eggs. But
I like to
eat eggs. But, I know what it is.
I like to eat eggs.
And
So you can tell that he knows that he's being asked to speak about eggs, so he is understanding what the clinician is asking him, but he's having a really hard time getting those words out, and he's clearly very frustrated. We'll watch the rest of the video in a moment, but what I want to show you is right here, this is an image of his brain. So this is just a T1 MRI where the areas in dark, and I hope you can see my mouse kind of tracing this at the second row, the farther left image. That's where the stroke happened to his brain. So as I said before, that middle cerebral artery, that middle portion of the brain is the area that is responsible for language. And he has a large amount of damage to this region. So this is what is causing his communication impairment. We'll talk about him again in a moment. So let's take a step back and talk a little bit more specifically about language in the brain and what kinds of brain damage may cause aphasia. So the question, where is language in the brain, has been one that's been asked for centuries. Early research in the 1800s by famous neurologists Paul Broca and Carl Wernicke, amongst others, hypothesized that parts of the brain were specialized. So for example, if we have region A that's damaged, function A is going to be damaged too. So they took a really modular approach to language in the brain and to other functions in the brain. Let's look at the work by Paul Broca and Carl Wernicke in a little bit more detail. So in 1840, a 30-year-old man was admitted to a hospital in Paris. When he was admitted to the hospital, he could only say the syllable tan. He often said it repeatedly and with varied intonation. So he would say tan, 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 but all he said was tan, and he's kind of affectionately been referred to as Tan Tan. He passed away, Mr. Laborn was his actual name, at age 51. And an autopsy by Paul Broca revealed that he had damage to the inferior frontal portion of his brain. So that's this area that you see right here. That's where that stroke damage was. And hence, Broca had referred to this area as Broca's area. And he said that because this individual had lost the ability to produce spoken language and had damage here, this is the region that must be related to spoken language. Likewise, Karl Wernicke was also a neurologist in Germany, and a little bit later, he worked with a man who had experienced a stroke. His patient couldn't understand spoken or written words, but he did not have a hearing loss. Upon autopsy, it was shown that he had a lesion in the posterior portion of his brain right here. If you can see my mouse, it's this kind of black area in the brain. And he concluded that damage to this area likely results in comprehension difficulty. So again, we're starting to see that kind of one-to-one correspondence between an area of the brain and a function. And this was a theory that dominated neurology for quite a while, that the brain was made up of these modules. You're probably familiar with Broca's and Wernicke's areas today. We still refer to these areas as such. So although early neurologists thought that the brain was made of modules, where one region was responsible for one thing, modern neuroimaging and technology has shown us that the brain really works together as a network. So even though one area might be damaged, areas downstream or functions downstream from that area might also be affected. We now have technology that lets us see pathways in the brain, and it's helped us really understand how the brain works together as a network. If this is something that's of interest to you, there's the Human Connectome Project, which is focused on being able to map the brain. And it's the goal of this project. And we try to do some of our studies to fit within the goals of the Human Connectome Project, is to understand how each region of the brain functions itself, but also how the whole brain functions as a network. So we've really moved beyond the early days of neurology, which said, one-to-one correspondence between a brain area and a function, to looking at the brain as a whole. So a lot of the work that I do really is trying to understand how a stroke affects a part of the brain, and how that stroke can affect not just that part of the brain, but how networks are affected in the loss of language, but also the recovery of language. So let's go back to aphasia in the brain. So one thing that researchers are attempting to do now is to really understand patterns of brain damage that cause aphasia. So what ultimately we hope to be able to do is to look at somebody's MRI, so their brain scan, and based on patterns of damage, be able to predict the types of deficits that they might have, so the difficulties that they might have with communication. And then can we take that information and use that to predict what kinds of treatments might be best for them? So a lot of our methodology relies on obtaining data from stroke participants. So what we do is we recruit individuals who have had a stroke, and we have them do various speech, language, and cognitive tests. What we can do is we can combine the results of those tests to individuals' neuroimaging. So these are just some example MRIs at the middle of your screen. The white areas are the stroke lesions. So this is a T2 MRI, which means that areas that are water or damage are bright. So you see the ventricles of the brain in the center, very bright. And then you also see that stroke damage on the left side of the brain. What we're able to do is to combine the behavioral data that we get from individuals, so their speech and language testing, with their neuroimaging, and then we can create predictions. So this is an example of some work we published in the past, where based on different results from speech and language testing and patterns of brain damage, we've been able to show that individuals with speech production deficits have damage to these regions in the warmer colors here, so the dorsal parts of the brain. And individuals with comprehension deficits tend to have more damage in the ventral parts of the brain, or these cooler regions here. We're also looking at how damage to these areas affects the brain networks themselves. So connections between areas in the left hemisphere, and then between the left hemisphere and the right hemisphere. And I'll talk about that a little bit more later. So let's go back to our individual with aphasia. Speech therapy is what individuals who have a stroke and have aphasia. Speech therapy is delivered by a speech language pathologist, and it's considered the standard of care for aphasia therapy. There's different types of therapies, so they may focus on the impairment itself. So thinking back to our individual in the video I showed you, this might be focused on helping him to be able to name objects again, or helping him put words together to form longer sentences. These are impairment-based approaches. Other approaches focus on training individuals to focus on their participation in life in the community. So this approach is the life participation approach to aphasia, suggests that even though an individual has this communication disorder, let's help them and the individuals around them really be able to get them back into their community despite this language impairment. In general, therapy has been shown to be effective, so that's very promising. However, as of this time, we do not have a cure for aphasia. So an individual who has aphasia that might be, say, 6 months to 1 year post-stroke, they still have symptoms of aphasia. It's likely that they will have that for the rest of their lives. Research is currently evaluating the effectiveness of one approach. I'll talk about speech entrainment to determine if it can improve speech production in non-fluent aphasia. And so some work from our group has shown so far that individuals with non-fluent aphasia, like the individual I showed you a few moments ago, this is successful in improving speech fluency. But one of the questions that remains is that no matter what treatment we employ, we tend to find that some people get better over time and some people don't improve. So one of the goals of our research in using neuroimaging is to understand why some people improve and some people don't, and if the answer might lie in the patterns of brain damage, either to specific regions themselves or as the brain networks as a whole. So let's go back to our example. Again, this is our same individual. He is 22 years post-stroke. I'll play the beginning of the video again so you can, just to refresh you about how his communication is. And then the second part of the video, I'll show you him speaking with speech entrainment, which, as I mentioned, is a treatment that we are currently investigating. And I'll explain that treatment once we get to that part of the video.
Try to say what you can about eggs.
Eggs. Eggs. But
I like to
eat eggs.
Okay, so again, see, it's very difficult and effortful for him to get even a little bit of speech out. So now he's going to be using speech entrainment or audio-visual feedback. So let me play the video for a few seconds and then I'll explain what's happening. So what's happening here is that he is looking at an iPod. I don't think they even make these anymore. But with the iPod, he's got headphones plugged in. So he's listening to the speaker while he's watching the speaker. So what's in the bottom left-hand corner of your screen right here is what he's seeing. So he's being provided with an audio-visual speech model, and the model is just restricted to the mouth portion of the speaker. And he's being asked to speak in real time along with the speaker. So as the speaker is speaking, he's attempting to speak as well. So let's look at how his fluency and his communication changes with this audio-visual feedback.
Like to eat scrambled eggs for breakfast. I like them
because they are fast and easy to make eggs and knit up in pan and melt some butter over medium heat. And crack the eggs into the pan and I like scrambled eggs best. No, until they are done.
Okay, so notice how different his speech was while he was speaking with the speech entrainment or the audiovisual feedback. Let's go back to his MRI here. Excuse me. And again, remember that he's got a very large lesion. So a very large portion of the left side of his brain is damaged. But somehow, with the aid of this speech entrainment, this audiovisual feedback, he's able to obtain more fluent speech. So notice that he had more words produced and his speech rate was relatively normal. It wasn't perfect, but it was a huge improvement. When we take that model away, the effect doesn't last. So now we're trying to figure out how we can have this lasting improvement with speech production with this kind of treatment. But some of our research has shown that just once you have several weeks of this treatment for at least an hour a day, it does improve fluency in speech to some extent. So let's go back to neuroimaging. Can we predict who will respond to different treatments? So this is a goal of a lot of neuroscience research that deals with individuals who have had a stroke. So using neuroimaging, we found that individuals with brain damage to Broca's area of the brain are more likely to benefit from speech and treatment. So this is image here. The areas in green are Broca's area, and individuals that have damage to that area are those who we've shown are more likely to improve with the aid of this audiovisual feedback. So it might seem counterintuitive that those with damage to an area that's important for speech production are able to improve speech production with this audiovisual feedback, but it may be that other parts of the brain are compensating. And that's what we're trying to understand theoretically, and also in with different types of neuroimaging, if we can really see how brain networks might change when somebody is watching an audiovisual speech model. So on the next slide, I've got a little bit more, some more results from some of our recent studies. So as I mentioned before, it's not just one area that's important, but connections between different areas in the brain. So it might also be that connections between the left hemisphere anterior and posterior brain regions are important for improving speech production with the aid of this audiovisual feedback. And it might also be connections from the left hemisphere temporal area to the right hemisphere homologue of Broca's area. So it appears that certain regions are important, but also certain connections between different regions are important. And just keep in mind that in the individuals that we research, no one has a stroke to that right hemisphere of the brain, so that should be healthier on that side. So some future directions with this work is really to develop models to help speech language pathologists select the best therapy approach for their patients. Can we understand how brain networks change during aphasia therapy? And can we learn enough about the brain to cure aphasia? So one interesting avenue that's some studies have started to explore are the potential of brain-computer interfaces to help individuals with disability caused by, for example, stroke. I think we're still some ways away from there, but definitely potentially in the next decade or so, an area of research that may be promising in this avenue. I did also want to, if you all are interested in learning more about aphasia, just aphasia in the media. So A Stroke of Insight is an excellent book by Jill Bolte-Taylor. She's a neurologist, neuroscientist who actually had a stroke and documents her experience with that stroke. My Beautiful Broken Brain is a Netflix documentary, which is also very interesting about an individual who had a stroke. And The Diving Bell and the Butterfly is an excellent book. It's also a movie. It's about an individual who has locked-in syndrome from a stroke, which is a little bit different. I didn't talk about that today, but a very interesting read. I do want to acknowledge collaborators and our funding bodies. If you all have questions, I can stay on for a little bit longer, but feel free to email me and I'd be happy to answer any questions that you might have.
Thank you so much. I am watching the stream right now, and currently there are no questions.
Okay.
I'm going to wait a second for it to catch up. But first of all, thank you so much. This was
Thank you for
interesting.
organizing this. This was wonderful.
Thank you so much for accepting my invitation. I'm gonna wait a few more seconds in case any questions come up. Yes, so here's a question. How does aphasia affect daily life? Are people with aphasia still able to complete tasks and take care of themselves?
It depends. So generally, the biggest impact is the communication piece. So if you think about the things that you do day to day, how many people you talk to, say you're going to working, going out in the community, asking somebody in the store to help you find an item, say at the grocery store. Just think about if you were unable to communicate, how that really would affect your day to day. However, individuals can do things for themselves. It's not to say that just because you have aphasia, you can't take care of yourself. Individuals are still able to, in some cases, unless mobility is affected, people can drive if they have aphasia. As long as there's nothing else that would impact them being able to drive, they can go shopping, they can do all those things for themselves, as long as there's no other effects of the stroke that would prevent that. But it really is the communication piece. So depending on how severe that communication piece is, people's deficits can range from very mild. So it might be very subtle word finding difficulties in conversation when they're tired, when they're fatigued. However, some people might have impairments like the man that I had showed in our video, very severe communication impairment. So it really depends on the individual, the severity of their communication impairment, and how that could affect their day-to-day life. So everybody's very variable.
Thank you. And so aphasia affects not only the individual, but his or her environment. How can the family handle or support an individual with aphasia?
That's a great question. There are training approaches for families. So one is called supported conversation in aphasia, and it trains not just the individual with aphasia, but also their family members and their communication partners on the best way to communicate with each other. So there's a lot of partner communication training that individuals can do, and speech language pathologists would be doing these treatments. So that falls under, I mentioned that life participation approach to aphasia, or the LPAA, that would really fall under that approach, where it gives the individual and those around them those strategies to communicate.
Thank you very much. And can neuroplasticity help overcome aphasia? Also, how is aphasia resulting? I'm sorry. Oh yeah, so aphasia resulting from dementia and stroke differ. So how do aphasia resulting from dementia and stroke differ? Sorry.
Yes, so I'll answer that one first, and then I'll go back to the plasticity. So I did not mention primary progressive aphasia during this lecture, I did not have time to cover all of that. But it has been shown that individuals can have aphasia due to a neurodegenerative condition. So for example, primary progressive aphasia, individuals have language loss that is aphasia. That's not due to brain injury, but actual degeneration to the language areas of the brain. There can be other degenerative conditions. Aphasia is associated. The biggest difference is that generally over time, those that have aphasia due to a degenerative condition continue to notice changes in communication, becomes worse over time. So just like dementia is a progressive illness, the changes in language do progress to a more severe state. Generally with stroke, individuals continue to improve over time, or they might plateau in their language abilities. So even though some early research shows that stroke-induced aphasia can be associated with some declines over time, it's not going to be nearly as striking as it would be with a dementia. And in terms of plasticity, we absolutely think that plasticity can help with aphasia recovery. One avenue of research is using brain stimulation, so transcranial direct current stimulation, or TDCS, to see if we can kind of help potentiate that plasticity. It's also thought that speech language therapy can induce plasticity. So for example, if you are working on targeting language, one treatment approach is constraint-induced language therapy, or CILT, and it really works on that principle of plasticity, that use it or lose it. So you're really focusing on using language to try to strengthen those networks. One thing we're trying to understand is how plasticity may differ based on the location and extent of brain damage. It's a big debate in the field of aphasiology if the left hemisphere has to recover for language to be regained, or if the right hemisphere can contribute, especially if that right hemisphere has not been damaged. So that's an excellent question.
Great, thank you very much. And could someone with aphasia communicate better with sign language? That's very interesting.
That is a very interesting question. Sign language would be difficult to learn. Individuals there have been some studies looking at gesture training, which obviously is not American Sign Language. But because ASL, or American Sign Language, or any type of sign language, is the language in itself, it could be difficult for individuals to learn. However, some approaches that don't involve speaking could be things like an augmentative or alternative communication device. And with technology, those have changed a lot over the past few years, but that could be an external device that an individual uses has maybe pre-selected words or phrases that they can use to communicate. There's even some iPhone and iPad apps now that can help promote communication if individuals are unable to speak because of their stroke. That is a really good question.
Great, thank you. And so does age affect the amount of recovery a person can recover from aphasia?
It can. So one thing that we generally, if you think about age and plasticity, principles of plasticity, younger is better, but we don't necessarily know if that's the case. So we are looking at seeing whether when people do therapy, if age is a factor that might predict how well they improve. And I think it's important because you think of plasticity as age dependent. So in a younger, if the system is damaged at a younger age, there's more of plasticity and potentially cognitive reserve to help get better. However, we have seen individuals who are older that still continue to improve. So one thing that our research has really shifted, and a lot of research in neurology and neurosciences that deal with clinical populations, is looking at brain health. So brain health is, as the name implies, the health of the brain. So things like age obviously can impact brain health, but so do things like diet and exercise, and just lifestyle factors. So is it that somebody's older but very active and very healthy versus somebody who's younger and maybe has health conditions that can affect the brain health, and that might impact plasticity?
Great, thank you. We have one last question. So other symptoms of strokes have been overcome by mimicking the way babies initially learned these functions. Can this be applied to speech?
So I think what that question is asking is if when somebody loses language because of aphasia, can we kind of regain language by how we would see children develop language?
I think so.
I think so, yeah.
Yes.
That was actually a very old theory that perhaps regaining language might kind of follow a similar developmental path. However, that's not what we currently suggest, that those are completely different processes. So if you think about a child learning language versus somebody who's an adult and has learned language and then lost it, it wouldn't be that same trajectory.
Okay, great. Thank you very much for your help. I'll just keep looking if there's any questions, and then I'll just email those to you. Thank you so much for your lecture.
Thank you so
very much
for organizing this.
Thank you for attending. Thank you so much. Thank you. So our next lecturer is Professor Eric Herzog from Washington University. And so his lecture title is What Wakes You Up? Network Clocks in the Brain.
Hi, Cynthia.
Hello. Yes, I can hear you. Yes. Thank you so much.
Okay. And let's see if I can share my screen. Let's try this again. Can you see that?
No, I cannot yet.
Okay. Let's try it one more time. Can you see that?
No.
Okay, I'm gonna just do one quick thing here. How's that?
1 second, your screen is frozen right now.
Okay.
Based on my settings, you should be.
Can you see that?
Now your camera is off now, so no.
Okay. Sorry, 1 second.
Of course.
How's that? Can you see me now?
Yes, I do. Yep.
Good. Okay, too many monitors. And let's try this. Can you see that?
No, unfortunately not.
Huh.
If you click on the bottom of the Zoom, the share screen thing, based on my settings, I think you should be able to share it. If you click on the exact PowerPoint that you want to share.
Okay.
Yes, perfect. Yes, thank you so much. Perfect, thank you.
Okay. Are you ready? Great, well, thank you, Cynthia, for having me. And what we're going to talk about now is a primitive part of the brain. So you've taken a tour of some of the higher level functions of the brain, and now I want to think about something that we all do. In fact, all living organisms on this planet are adapted to the fact that we have day and night on this planet. And because you guys are interested in the neurosciences, I'm going to focus on what I call the network clocks in the brain. And what we're going to be looking at today is the idea that there are clocks within the brain that regulate daily rhythms in things like sleep and wake. And these clocks need to synchronize to the local light-dark cycle. And because there are many of them, they need to synchronize to each other to drive coordinated rhythms in behavior. So here's the take-home messages for today's lecture. We're going to talk about how there are circadian rhythms. They're ubiquitous across all cell types and across life. We're going to talk about how cells generate and synchronize these daily rhythms. And then I'll give a few examples of sleep disorders, brain cancer, and preterm birth as examples of how this sort of new area of biology can be applied. So I'm going to try a little exercise here. I'm going to ask you one question, and I need you guys to go to the internet and answer this question. When did you wake up today? And so what I want you to do is open up a web browser and go to this poll, polleverywhere.com, and then /Eric Herzog 238. And you should see, if everything's working, a window that looks like this. And I'll need you to just click on the time of day when you woke up. And I'm just interested in the time when you woke up and stayed awake. So don't tell me about when you woke up, went to the bathroom, then went back to bed. And then we'll just watch your results here on this poll. Let's see if that's working. So if folks are able to, yes, good. We have our first vote from somewhere in the world. Somebody woke up at about 8 in the morning. Can we get more responses? I'll wait a few more seconds.
The live stream usually lags a few moments, so.
I see. Okay, I'll count to 10.
Yeah, someone is asking me to post the link. I will post the link.
Okay. It's also here on the screen. There we go, good job. Super, and as we see the results coming in, we're seeing something that looks like a distribution. And as young scientists, you guys are all used to the idea of describing a distribution like this, where we're looking at the number of people as a function of what time of day they woke up on a free day, like last Sunday. And we see that high school students around the world tend to like to wake up somewhere around 8 to 9 in the morning, if not a little bit later. There are a few early birds in the population, and there's some extreme late birds in the population. And as these data come in, we'll see that this distribution tends to be sort of shifted a little bit later than you might imagine the distribution would be for your parents. And so with those results, thank you all very much for contributing to our little experiment there. What we can see is that the distribution is skewed to the right a little bit here, and high school students tend to wake up a little bit later, with very few students waking up early in the morning. Some of them are even changing their mind in real time. So in the interest of time, I'm going to move on and tell you about what it is that helps determine when you wake up each day. So if we do a survey like that and we ask several 100,000 people around the world what time you prefer to wake up, and we plot that on the y-axis as a function of age, we see that high school students are here tending to wake up later. And if you're at the peak of your distribution, about 19 and a half years for women, and about 21 years of age for men, you reach the latest point in your daily preferred wake-up time, something we call your chronotype. And then what you have to look forward to is as you guys get older, you're going to get progressively earlier and earlier and earlier in your schedule until somewhere around the age of 55 to 60, close to retirement, you'll be getting up about as early as you did back when you were a small child. So this preferred wake-up time is something that is characteristic and different as a function of sex and as a function of age. And we can think about what is it that drives this preferred wake-up time, your chronotype. So what is it that woke you up in the morning? If you're a typical high school student, you'll probably tell me that you woke up with an alarm clock on any school day. It turns out 80% of people in the working world use an alarm clock to wake up on any working day. And then on free days, some people will not use an alarm clock. So I want to know what it is that wakes us up if we don't use an alarm clock. And then people will say, oh, my mother, or the sunshine shining in through my window. And I'll say, okay, those are all things external to you that woke you up. What if we put you into a cave and we took away the light-dark cycle? We took away your access to time, to clocks. Would you still wake up and go to sleep on a daily basis? Many high school students tell me, I would never wake up. I would sleep forever. But in fact, we see that we do wake up and go to sleep even when we're isolated from any wake-up cues in the environment. So I can illustrate that for you here in data taken from a mouse in my lab. In this case, what we're looking at is the mouse running wheel activity. And I'm going to really try and use a lot of raw data to show you guys some of the principles here. So what you're looking at is how much the mouse runs on the y-axis as a function of time on the x-axis. And in the beginning of this record, the mouse is in a light-dark cycle where the lights are on from 7 a.m. to 7 p.m. And then they're off until the next morning. What you see is the mouse prefers to run at night. It's a nocturnal organism, and it rests during the day. And then when we turn the lights off completely and leave the mouse in total darkness, that daily rhythm in activity persists. It's built in, it's an intrinsic circadian rhythm, a rhythm with a period of about 24 hours. So it's something that is biologically driven. And if we just listened to our bodies, we would have a daily rhythm. We think that this is adaptive, that this is useful for the organism. And we can show that in a couple of different ways. Here I'm plotting the same kind of data, here locomotor activity, in this case for an individual, a person, who's wearing a wristwatch that measures their motion. So something like a Fitbit, if you're familiar with a Fitbit. And on each line, we plot when they're active and when they're resting. And in this case, the individual was active during the day and relatively inactive at night. And then on the following day, they were active. And then that continues down onto the next line. And what we see if we just read down the plot is this person was waking up every day at exactly the same time. And then they experience a very rapid shift in the light schedule. They fly to a new time zone. In this case, they fly 8 hours east. And what we see over the subsequent days is that their activity is synchronizing gradually over 1, 2, 3, 4, 5, 6, 7, 8, 9 days. Eventually, they get back onto their original schedule. And what they're doing is they're synchronizing their daily rhythm to the local light-dark schedule. And what you're looking at is, of course, an example of jet lag. And the way we think about how this system is built is a simple system that's comprised of a clock that needs to synchronize to the light-dark cycle to drive normal rhythms and behavior so that they're synchronized to local time, so that you're getting up with sunrise, you're getting your food at the right times, you're avoiding predators, etc. And for the rest of my talk, I want to focus on the idea that there's not just one clock in our body, but in fact, there are many clocks. And these clocks synchronize to each other in the same way that they synchronize to the environment to allow for a coordinated daily rhythm in things like sleep and wake. So where is this biological clock? I'm going to show you a short video here generated by Joe Takahashi at the University of Texas Southwestern, an HHMI investigator. And I'm going to talk you through this. Let's see if we can get this to work. No. Come on, play. Okay, I'm going to describe for you what's happening in this video. Light coming in from the environment enters through our eyes, and the light signaling through our eyes is the primary way that we synchronize to our local to our local environment. So other cues that might give you a sense of what time of day it is are less important, but light is the most critical. And that light signals through your eye, down the optic nerve, into the brain, and it impinges on a structure called the suprachiasmatic nucleus, or the SCN, and it's my favorite spot in the brain. The SCN is a master circadian pacemaker. It's sort of the conductor of the orchestra of all of the clocks in our brain and in our body. It receives that light-dark information from the environment, and it transduces that information into a sense of, okay, that was morning, that was evening. And then within the suprachiasmatic nucleus, just on the base of the hypothalamus, in the left and right sides of the brain, there are about 10,000 neurons that are able to keep daily time. They are electrically active during the day and relatively quiet at night. And they keep time and they synchronize to local time through their electrical activity. Their electrical activity then drives activity elsewhere in the brain and in the body to tell the rest of the body what time of day it is. And so how is it that these cells within the SCN keep 24-hour time? Well, this was a really exciting story that's developed over the last decade or so. And the idea is that there is a molecular, genetically determined clock inside of individual cells. And it's this molecular clock that controls daily rhythms in gene expression and in behavior. So just to illustrate how we think that clock works in a really simple way, imagine you have a cell, and this line represents a gene. You have roughly 20,000 genes in your body. Of those, about a dozen are considered clock genes. Those clock genes, when expressed, make their mRNA, their messages. Those messages are translated into clock proteins. Those clock proteins then accumulate as the gene is on for a longer and longer period of time until enough of the protein is accumulated to go back into the nucleus, turn off the clock gene, and that causes the transcripts to start to go away, to degrade. The loss of those transcripts causes a loss of protein. The loss of the protein causes a loss of repression, and the gene can turn on again, roughly 24 hours after it had started its cycle the day before. So here we have an intracellular molecular clock that's genetically determined. And we can actually watch how that clock ticks in real time because we've started to identify some of those essential clock players. Here's a schematic representing one of the clock proteins, a protein clock gene called the period gene, because mutations in the period gene cause changes in our daily rhythms. They can speed it up, slow it down, or even if you delete this gene, cause a complete loss of daily rhythms. If this gene is turned on, its protein accumulates. That protein goes back into the nucleus to turn off the transcription of that gene. So the transcripts go away, the proteins go away, the repression goes away, and the cycle can start anew. We can actually watch that. Oh, and very exciting, this work was recognized in 2017 with the Nobel Prize for Medicine and Physiology, awarded to Jeff Hall, Michael Rosbash, and Mike Young, who did their work in fruit flies and discovered this molecular transcription, translation, negative feedback loop. So we can watch this clock now turn on and turn off in real time by actually making transgenes that glow when our gene of interest, like the period gene, turns on, or when its protein accumulates in abundance. So what you're going to see now is a movie of the SCN, the population of about 10,000 cells on the left side of the brain, 10,000 cells on the right side of the brain. And this movie runs for about 3 days, sped up. What you see is 1, 2, 3 days of daily gene expression, and it just keeps repeating. And you can see the individual cells are turning on their genes and then turning off that per gene on a daily basis. We can reduce this complicated system down to just the SCN in a dish and watch that clock in a dish tick and begin to ask questions about, are all of the cells within the SCN capable of generating their own time? Or are just some of them sort of the grandmothers telling all the others what time to wake up in the morning? So here's an experiment we did, work by an undergraduate and a graduate student in my lab a few years ago, showed that if we just plate cells on a cover slip in a dish, and we then watch their per gene expression over time, for example, from this cell highlighted with the arrow, we see the gene turns on, turns off, turns on, turns off over the first 2 to 3 days that we record. It's at this point that the students then went in and they stabbed all of the cells in the dish and killed them. They called it their Arnold Schwarzenegger experiment, except they spared one cell. And that one cell lived, and all by itself, it kept on ticking with its own intrinsic rhythm. So this was the first demonstration that single cells truly are all by themselves capable of keeping 24-hour time. They repeated this experiment a little over 1,700 times on different cells and found any cell type that they did was capable of keeping near 24-hour time. So different cell types within the SCN, and even cells within the skin, the cornea, your heart, your lung. We can do this same sort of experiment on human cells, putting a real-time reporter into human cells, and we see that those cells have intrinsic 24-hour rhythms. They are circadian pacemakers. So what I've told you so far is that these circadian clocks are cell autonomous. They exist within single cells. They're genetically determined, and they are ubiquitous within the body. We think of the SCN as sort of the atomic clock that coordinates all these other clocks, like the clocks in our computers and the clocks on our walls that are synchronized to the atomic clock. So how might these clocks be relevant to all of us in our daily lives? For example, now as we live in an era of COVID-19, your sleep-wake schedule is probably different than it was when you were going to school. So we've already talked about how it's relevant in terms of jet lag. Now I want to talk about how it's relevant to a very large and growing population of people in the world that do shift work. They work nights some days, days other days, and work on different shifting schedules. Or all of us are used to experiencing the shift from standard time to daylight saving time. This is observed by several billion people in the world every year. As we spring forward and then fall back, we need to adjust to those shifts in our daily schedule. And another term that may be new to all of you is something called social jet lag. And this is really important for high school students. Social jet lag can be illustrated here. Social jet lag is where you keep a daily schedule, for example, here for 5 days in gray, where this individual was going to work on a pretty regular schedule. You see here when they went to bed and when they woke up. And then for 2 days each week, you see they go to bed later and they sleep later. And then they go back to this 5-day, 2-day schedule over the course of this recording. If we calculate just the middle of their sleep during work days and during sleep days, we see there's a big shift of about 3 hours from here to here, representing something we call social jet lag, a 3-hour social jet lag in this individual, which is the result of keeping a social schedule that's different from our biologically preferred schedule. If you measure this in a large population of people, you see that most people have at least some social jet lag. High school students tend to be in this area here with about 3 to 4 hours of social jet lag. The good news is that as we get older, because of our natural tendency to wake up earlier and for society to schedule things to start early in the morning, our social jet lag gets less and less. So for those of you who are feeling completely sleep deprived and desperate, the news is hang in there, it gets better. The bad news is that social jet lag is associated with many negative health effects. For example, some of the things that we've been talking about today in the other talks, the ability to metabolize and control our body mass is impaired, and we see increases in body weight and obesity as social jet lag increases. Increases in mood disorders such as increased aggression, depression, increased addictive behaviors such as smoking, and for those of us who really care about how we're doing in school right now, poor grades is associated with social jet lag greater than 2 hours per day. So are you doomed? No. There are things you can do even now in this era of COVID-19. And I'm going to draw on a beautiful story from some college students that were studied at the University of Colorado. In this actogram that you're looking at here, you see activity of a college student on their regular daily schedule as they go to classes and hang out with friends for a little over a week before they come into the lab and they get evaluated by a scientist. And then the scientist takes the college students camping, literally camping. They go on a trip and they spend some time outside. And you can really see the difference, first of all, in the yellow here, which shows their light exposure. In their regular schedule, they're indoors, and so the light levels are relatively low. There's some light that's occurring at night because they're looking at computers and they have their lights on. Then when they go out into the natural world and go camping, light is very bright, and there's almost no light at night that's detectable in their recordings. And then if you look at their locomotor activity, you see their onsets of locomotor activity shift earlier, and they have much more activity, and they have no trouble falling asleep. They have really good consolidated sleep. And so if we just summarize those data here, you can look at the sleep in bars here during the time when they were experiencing electrical lighting, and then when they went out camping under natural lighting. These college students naturally woke up earlier and had a longer night of sleep just by going camping. And that may be familiar to many of you. So if you are thinking, how can I help myself to wake up a little bit earlier to anticipate my next work day, think about things like getting as much natural light as possible. Is my bed near a window so I'll get light in the morning? Am I doing filters on my computer screen so I minimize how much light I get at night? My lab is particularly interested in how these clocks are relevant to human health. And sometimes your daily schedule is really important to your health, as we've mentioned. So here's a nice record from an individual who we recorded for several months before their life dramatically changed. At this moment right here, this woman had a baby and her life was changed forever. And you can see it in her sleep-wake schedule. And in fact, we've been following women before they get pregnant, and we've found that if a woman has a regular daily schedule, she's more likely to deliver full-term healthy babies. However, if she has an irregular daily schedule, her likelihood for preterm birth is increased. And we think this may relate to the idea that she has circadian clocks, for example, in her reproductive tissues, and her developing fetus has a circadian clock. And synchrony between mom and the baby during the pregnancy may be critical for having a healthy, normal pregnancy. My lab is also working with oncologists on thinking about how we might be able to help treat cancer. All of us are comfortable with the idea of taking certain drugs at certain times of day. For example, many students will take caffeine. And here in this comic, these two cowboys are competing hour after hour, cup after cup, in matching their caffeine limits in the traditional contest of the Old West. So there's no culture in the world that doesn't consume caffeine as a stimulant during the day. But did you know that caffeine taken and the equivalent of an espresso taken after 3 p.m. in the afternoon will delay will not only keep you awake now, but will also delay when you wake up the following morning by about 45 minutes. Think about doing that every day, struggling to wake up in the morning because your caffeine in the afternoon was shifting your clock to wake you up 45 minutes later. So we're thinking about this chronotherapy or circadian medicine as a good thing, something we can use to try and treat cancers. So we've found that human glioblastomas, brain cancers, also have daily rhythms in gene expression, just like normal neurons and astrocytes, glial cells in the brain, have daily rhythms in their gene expression. And we've been able to show that the sensitivity of these tumor cells to the drug that's been used for the last 20 years to treat glioblastoma varies dramatically with time of day. So if we treat these cells at the time when they have peak PER2 expression, they are extremely insensitive to the drug. Whereas if we wait till the time when that period gene is at its minimum, we can kill the tumor. So there are daily variations in sensitivity to drug that may inform best treatments for different diseases. And so here's what I've told you today. There are circadian clocks everywhere. These clocks are ancient. They probably evolved with life on this planet. They exist in all living organisms, including single-celled organisms, plants, fungi, and humans. And normally these clocks synchronize to the light-dark cycle to allow us to anticipate what's coming next. And when they get disrupted, as with shift work or other forms of chrono disruption, we are at risk for different kinds of diseases. So what next? If you're interested in learning more, I encourage you to visit my lab's website, where I have references and resources for people who want to learn more about circadian rhythms. Dr. Arnsten mentioned brain facts earlier, and I encourage you to look at the Society for Neuroscience's website, where we've got information about circadian rhythms and sleep targeted at young readers. And then if you, as high school students, would like to learn more about the brain, I encourage you to look into competing in a local brain bee. In St. Louis, we have the St. Louis area brain bee. And there is actually, if you win your local bee, you go to a national bee. And then there's an international brain bee that I encourage you to seek out. And with that, I thank Cynthia, I thank all of you, and I thank all of my collaborators and friends in St. Louis who participate in what we call Clocks Club, studying the circadian system from input to oscillators to output. And I'll be happy to take any questions.
Thank you so much for your lecture. I think we can all really relate to how our sleep schedule is pretty off right now. Thank you so much. So the first question says, how much does blue light from screens affect sleep?
Good. Blue light from screens has two major effects. The first one is it's actually alerting. So it's acutely stimulatory through some of the signaling pathways that you've heard about today. Noradrenaline is actually released in response to light at night, and we seem to be particularly sensitive to blue light. In addition, that light is going through our eyes, signaling through a really cool new pathway, a new set of photoreceptors that were discovered to synchronize us to local time. And blue light is particularly potent in signaling to the circadian clock to synchronize us to local time. So one thing all of us might think about doing is putting on one of those filters that you see on your computer screens and your phone screens as an option. The evidence, for example, for f.lux is quite good, that it can help people fall asleep at night and alleviate some of the shifting of your clock in the morning.
Thank you so much. And it is well known that depression changes sleeping patterns. So how does that occur in the brain?
Fantastic. It's a two-way street with depression and sleep. So it looks like in some individuals where you have disrupted sleep, for example, today I focused on how the circadian clock controls sleep, but there are other things that control your sleep as well. For example, every minute that I keep you awake, you are getting sleepier and sleepier, so that by the end of a long day, your sleep homeostat, a sort of hourglass, flips over and says it's time for you to go to sleep. So in depression, where you maybe are perseverating on some thoughts, you're having trouble falling asleep because of other factors in your life, you are disrupting your sleep. And then it turns out that disrupting your sleep can lead to depression. The mechanisms by which that happens are not entirely clear, but you heard today a little bit about some of the circuits in the limbic system that control mood and how we feel reward. Many of those signals, dopamine, for example, are circadian in the brain. They vary with time of day. And disruption of that normal rhythm seems to lead to mood disorders.
Thank you very much. And so what is the main reason that our sleep schedules are different during COVID-19?
The main reason, I would love to have the answer to that. In fact, the pregnancy study that I just mentioned to you is ongoing. We have women who are wearing watches that got pregnant before COVID-19, and they are still wearing the watches during COVID-19. And so we will see how their sleep schedules have changed. And many of my colleagues around the world are collaborating as we collect data during COVID-19. The main reason I'm guessing that high school students' schedules are different is you no longer have to get up and go to school. And so maybe COVID-19 has some small benefits. The students that I've interviewed over the last few years who are homeschooled and can dictate their own schedules, they don't show any social jet lag. They wake up every day at the same time. Unlike a typical high school student who has 3 to 4 hours of social jet lag, sleeping in 4 hours on the weekends compared to weekdays. And that's as many time zones as we have in the United States on a weekly basis, shifting like that. So I think the idea of COVID-19 allowing you to obey your biological clock instead of your alarm clock is the main difference.
Thank you very much. And how many hours before you go to sleep should you stay away from bright light?
That's a great question. It turns out light during the day has very small, if any, effects on your circadian timing. It's really light after dusk that's going to tell you, ooh, I need to shift. So think of it this way. If you see light after dusk, your biological clock thinks, oh, dusk came later than I expected. And it shifts so that you wake up a little bit later. If instead you get light just before dawn, your biological clock interprets that as, oh, dawn came early, and it shifts you earlier, it advances you. So if you get light at dusk or after dusk up until about midnight, you will delay yourself. It's sort of like flying west. If you get light just before dawn, you will advance yourself. That's sort of like flying east. And most high school students are interested in trying to wake up earlier. They have no trouble waking up later. So if you want to try and wake up earlier, you want to focus on avoiding light from, let's say, 6 p.m. till midnight and seeing light from midnight to 6 a.m. So getting light in the early morning hours can help us wake up earlier.
Thank you very much. And so are circadian clock rhythms genetic?
Yes, and I'm glad you asked that question. The period gene that I mentioned today is heritable. And there's a family, for example, in Utah that has a mutation in the PER2 gene that causes them to wake up early. Every day they wake up at about 3 o'clock in the morning, and they go to bed every night at about 7 o'clock at night. They have what's called familial advanced sleep phase, FASP. And that mutation, if we put it into mice or fruit flies, they also wake up early. So if you are struggling to wake up early in the morning and your parents are complaining to you that you're lazy, you just tell them, well, my circadian clock is inherited, and so you are responsible for my daily schedule.
Thank you. That is good advice. We will probably all remember that. So the next question asks, what is the best time high school should begin school?
That's a really cool question. This is an ongoing active area of study. There are schools in different countries that are trying different experiments. You guys probably know as much as I do about how much high school students struggle to get to school at, let's say, 8 o'clock in the morning, or even earlier if you have an early school or you do athletics before school or other clubs. So right now, the recommendation from the American Sleep Society is that high schools should start somewhere around 9 o'clock in the morning, but we know that that might also still be too early. There's some extreme experiments being conducted. There's one school in England that's starting classes for high school students at 1 o'clock in the afternoon. There are schools in Brazil that allow students to choose which schedule they want to have. It's such a big high school that they actually have a rotating schedule where some students come early in the morning and other students elect to come late in the afternoon. So the best time is something that's genetically determined and epigenetically determined for you, meaning it's partly due to your parents and partly due to things like how old you are. And you will know on Saturdays when you prefer to wake up and without any alarm clock, that's when your high school should start.
Thank you very much. And then one last question. Why do we sometimes wake up during the night and can't fall asleep again? Also, even after sleeping enough, why do we feel tired in some mornings?
Fantastic. There are a lot of reasons that we can have disturbed sleep at night. Circadian clocks would be one possibility. If you think about the idea that there are many cells within the SCN that are driving daily rhythms in sleep and wake, those cells, if they are not able to keep time, for example, because of a tumor or a mutation or a stroke that's disrupted the SCN, those individuals will actually have a hard time sleeping through the night. So disruption of the circadian clock is one way you can have disrupted sleep. But insomnia is very common in this world. Almost 80% of people will say they have insomnia at least twice a week. And those insomnias can be caused by breathing disorders, mood disorders, and other neurological disorders.
Great, thank you very much. I think that was it for questions. Thank you again for your lecture. Thank you so much for accepting my invitation. This was so interesting. Thank you so much.
Thank you, Cynthia. Bye-bye.
Thank you, bye. So our next lecturer is Professor James McGaugh from the University of California, Irvine. And I'm going to start this. And his lecture title is Making Lasting Memories.
Am I on?
Your video is not on yet. Yes, great. Thank you very much.
Well, hello, everybody. It's very nice to be with you. And I'm going to talk with you about memory. And the reason I'm interested in memory is that it is our most important capacity. As a matter of fact, we wouldn't be alive without it. I want you to think about this for a moment. That moment is gone. That moment is past. And what memory does is to integrate moments to moments to give you continuity in life and allow you to predict the future. Now, William James, a very famous psychologist in 1890, asked the question that you see there. He says, of some experiences, no memory survives the instance of their passage. Of others, it's confined to a few moments, hours, or days. Others may be recalled as long as life endures. How can we explain these differences?
Excuse me, your screen is not shared.
Okay, how do I share my screen then?
On the bottom, you click on share screen and then choose the PowerPoint that you have open.
No, I'm looking right at my at the figure. I can't see a bottom.
Can you go back to the Zoom where you came into the call?
There's nothing on that Zoom. Just a second. Just a second. Okay, share screen.
Yes, share screen, and then you can click the PowerPoint.
Okay, I hit share screen.
It is not sharing yet.
Just a second. It's not allowing me to go to my PowerPoint. Is that on now?
No.
Is it on
Oh yeah,
now?
it just started. Yes, perfect. Thank you so much. Thank you.
Okay, but it's not, it's, okay, just a second. All right. All right. So I just said that memory is the glue of our experiences. So we have an experience of the moment right now. And by the time I finish that sentence, the first part of the sentence is a memory. And so what our brain does is to glue this all together so that we have continuity in our lives and we're allowed to predict the future on the basis of this glue. Now, why is it that some experiences are short-lasting and other are long-lasting? Well, that's been the focus of my research for many decades. Now, an insight was given by Descartes, a philosopher many years ago, when he said the usefulness of all of the passions, all of the emotions, consists in their strengthening and prolonging in the soul thoughts for which it is good for it to conserve. That is, the usefulness of emotions is to strengthen memories which are important to conserve. And I'm going to tell you what we have done in my laboratory to investigate this very question of taking weak memories and turning them into strong memories, the way the brain does that for important experiences. Now, what happens when you have an important experience? When somebody says something to you which is slightly stressful, or something which is slightly important, or very stressful or very important, two things can happen. On the right, you see brain activation leading down to the release of adrenaline or epinephrine. And on the left, you see arousing, activating the anterior pituitary, the adrenal cortex, leading to cortisol or corticosteroid. These are things that happen just naturally occurring all the time when there's a little bit of stress or a lot of a stress of occurring. Now, the question is, what do these things do to influence the strength of memories? Well, to investigate this in many experiments, and I'm just going to show you a few, we have trained rats, and here is a simple experiment. A rat is placed in this chamber, and you can see a white rat there, and it walks through into the gray area where it receives a mild electric shock. And the question is, does the animal remember that? Well, if the shock is very low, the animal will not remember it very well. If the shock is very high, the animal will remember it. And we asked the question, why does the animal remember it? And one of the answers is because it releases a lot of adrenaline when the shock is high, and that adrenaline has actions on the brain which strengthen the processes underlying memory. So here's the experiment that was done in my laboratory by two of my students many years ago. Animals are trained in this apparatus and they're tested the next day after they'd received a slight shock. And as you can see, the animals remained in the starting chamber for about 60 seconds. These are saline controls. If the animals, on the other hand, were given a dose of adrenaline immediately afterwards, here's what happened. If they get the dose immediately afterwards, the memory is very significantly enhanced. If the injection came a little bit later, it was less enhanced, later less, and 2 hours later, not at all. So that says there are time-dependent effects of the activation, in this case, administration of adrenaline after training, which affect the strength of the memory. And that memory we've tested will last for a very long period of time. Now, what that is suggesting is that we have within us the ability to control the strength of our memories simply by activating these systems in the brain. Now, what systems in the brain? For other reasons, we were working on a structure deep within the brain called the amygdala. Many of you may be familiar with this structure. You can see where it's located here, right at the tip of the hippocampus, and the yellow bar shows you where it is. So we've investigated the role of activation of the amygdala by adrenaline in producing the effects on memory. So let me show you. Here's an experiment that we did with a very, very simple task. An animal, in this case, a rat, a mouse in this experiment, is put into a box that has two objects, two light bulbs. And the mouse just looks at these two objects. And the next day, we test them to see which objects the animals pay attention to. Turns out, if they remember, the animals will pay attention to the objects that they had not seen before. After all, it's boring. They're familiar with this one, so I pay attention to it. Now, what we did in this experiment was to expose the animal to the objects here and then give them a post-training injection of norepinephrine directly into the amygdala after training and looked at the retention the next day. And here are the results. Here are animals that got saline injection into that region of the brain. Here are the animals that got injections of norepinephrine, and you can see greatly increased memory with these doses. We also, in other animals, gave them propranolol, a drug which blocks the action of adrenaline and noradrenaline. And here are the saline controls with animals that were given a lot more training on that day. And you can see that propranolol given to that region of the brain completely blocked the memory. So what you're looking at here is the regulation of the formation of memory of this simple object that animals are looking at. And the memory can be made stronger by application of norepinephrine, which can be normally released, and it can be made weaker by blocking that action. Now, the question is, this was work that we have done experimentally. How does it work normally? Is norepinephrine released in that region of the brain, and does that influence memory? Well, the answer to that is yes, as shown by this experiment. So here are animals that are sitting in the apparatus, the shock apparatus that I showed you. They're just sitting there. And then at this point, they get training. And what you see here is we have measured norepinephrine, which is released in the basolateral amygdala of individual animals. So the animals are sitting here, and this is an individual animal. And we now have measured the norepinephrine in this region of the brain. And you can see that it is very high. It's less high in this animal, and so on down to this animal in which it's not released at all. So here are individual differences in the amount of norepinephrine that's released in the amygdala by the training experience. Now, if you look to the upper right, you can see the retention displayed by these individual animals. This animal never went back into the region where it had been shocked, even though it was sitting there for 10 minutes. It was complete avoidance. Whereas this animal that released no norepinephrine in this region walked back in 10 seconds. So what you see here, this is not, we didn't do anything to the animals except train them and measure the norepinephrine. And what we found is the greater the norepinephrine released by training, the stronger the memory at a later time. This indicates that this is a regulatory influence of the normal release of norepinephrine on the strength of memory at a later time. Now, we've also looked at this in humans in many ways, and I'm just going to show you one experiment that we did. In this experiment, human subjects were exposed to movies, short movies, very, very brief, for a period of time. And at the same time, their brains were being examined by PET imaging, emotional positron measurement of their brains at that time. And then what we did was to measure the memory of the film that they had seen a couple of weeks later. And what we found is that the the greater activity of the amygdala during the viewing of the films, the stronger the memory of those films when tested several weeks later. And you can see that in the plot that is shown here. Here is very low activity in the PET imaging and very poor memory. And here is very high activity and very good memory. So we saw that with norepinephrine in the rats, and now we see that with PET activity in humans. It's the same thing. The greater the activity of the amygdala, the greater memory will be at a later time. Now here's a picture that I've created to show what we think is happening here. Here's a learning experience. And normally with the learning experiments, there will be an activation of various regions of the brain, the cortex, the hippocampus, the caudate nucleus, other brain regions. All of these are going to get activated by a simple learning experience. Also, the basolateral amygdala, the region where we have been injecting the substances and measuring the activity of PET in the case of the human subject. And also the adrenal gland is going to be activated. So that just happens when you have any kind of an experience. Now, if it is a strong memory, a strong experience, then that adrenal gland will be activated, release epinephrine, which will turn on the release of norepinephrine in the basolateral amygdala. It'll also cause the release of glucocorticoids, and these will go directly to other regions of the brain, and they will say, in effect, something important happens, make a stronger memory of what just happened. So here's the learning experience, here's the activation of the brain regions, and these are the modulating systems that will determine how strongly the changes will take place in these other brain regions. So one answer to the question that was raised earlier, how can we explain the differences in memory that are created by experiences? Here's how we can explain the differences. To some degree, it's the activation of this particular modulating system here in the brain, which influences then changes in other brain regions where different forms of memory are occurring. Now, a number of years ago, I got an email from a young woman, and she said, I have a memory problem and I would like to talk with you. Now I ask you, what would you think if somebody said, I have a memory problem and I'd like to talk with you? You'd probably think what I thought. And I thought that she had a loss of memory, that her memory was impaired and wanted some advice. Well, no, that was not the case. She said the problem was that she remembered too much. Her name was Jill Price, and she's written a book entitled A Woman Who Can't Forget. So she came to me and I decided to talk with her. And she said that she can remember most of the experiences in her life. She can remember the day on which they occurred, the details of the event. And this went back to the time that she was an early teenager. So we published a paper reporting her ability to recall her experiences. And by the way, we documented, I could ask her almost any day of her life, and she would tell me what she did. And we could document that because she kept a diary, and we could look into the diary and see whether or not what she said had occurred did in fact occur according to what was in the diary. So we were convinced that she did indeed have this ability. We obtained some publicity about that. And so people began to contact us, and we tested a very large number of people who contacted us. And we ended up with about 60 people in the United States who did have the ability. And I'm showing you here what this looks like. We gave them a 30 question quiz, and you can see the performance. Here's the percent correct, and here's the number of people who have that particular score. Now here's us. Here's the normal people in orange here. Distribution of the percent correct. The average is about 15 correct, and you can see the distribution. I'm sorry, 15%, and you can see the distribution in orange here. Then over here, starting here, is the distribution of those people who claim that they have this ability to remember every day of their life and what they were doing on that day. And you can see there are people who have a very strong ability, and furthermore, that the two distributions are different. Here's the orange, and here's the others. Over here in white are the people who claim that they have the ability but did not. And they are just like normal people, even some people who are worse than normal for reasons I don't know. I'd like to know what's going on in their brains. In any case, these are the people who have this extraordinary ability of remembering most of the days of their life and what they did on those days. Here's an example of the kind of things that we did with them. We asked them to tell us the day of the week for a great number of days. And you can see that the subjects in blue who had the ability were almost 100% for any day of the week, for any date that we would give them, whereas we are at chance if you don't have the ability. We ask about a verifiable event, such as when did a plane crash occur, or some important event that occurred that everybody would have experienced. And the people who have this ability are superbly able to report the day of the week, and those who do not have the ability are hardly able to do that. We asked them about a very specific autobiographical experience of their own, and these individuals can report accurately, and we cannot. So these are very unusual ability. It's a very low incidence. We have in our study over the past 20 years identified fewer than 200 people in the United States who have that ability. I presume that there are more, but if there are more, there are not many more. So it's a very, very unusual ability to have. Now, here are some characteristics of these individuals. They're highly accurate in their autobiographical remembering. Going back many decades, they can tell the day of the week for any date. They can tell us accurately the dates on which any public event occurred. Now, surprisingly, they're not exceptional in learning and laboratory tests. So they're not just good learners in general, they're very good about their personal autobiographical experiences. We got one clue which we'd like to know more about, and that is that they are all compulsive. They show obsessive compulsive behavior. They are germ avoidant. They collect things. They organize things excessively. And this is true of all of the subjects that we have tested. So there must be some relationship then in the brain between this compulsiveness and the highly superior autobiographical memory. Now, we have looked at the brain and we have a little bit of evidence so far, not as much as we would like. This will give you an example. We have scanned the brain to look at the structure of the brain, first of all, and we found that there are several brain regions in these subjects that differ from those of controls, and one of them is in the left parahippocampal gyrus, the region that I'm showing here, the cross in the middle, right here. And there are 3 or 4 other regions also in which there are anatomical differences. The brains are either slightly larger, slightly smaller, or different in shape. So this is just the beginning of an anatomical analysis of these brains. We don't have a complete story, but at least we do know that their brains are slightly different, and we need to know more. Now, here are some questions for future research on these subjects. Is there a genetic basis? Well, we don't know yet, but we know that we're collaborating with a laboratory that is now investigating this. We have sent them genetic samples and they are analyzing it, and we will know sometime soon whether there is a genetic basis. Another important question is do these subjects store the material more strongly, or do they have exceptional retrieval? Think about it for a moment. When you learn something, generally, the more you study it, the better you learn it, the easier it is for you to retrieve. but are these independent abilities? If you think about it for a moment, can you remember the last time that you went out to a restaurant? Can you remember that? Can you remember the last time you went out for a restaurant 5 years ago, for example? Now, these people can do that, but is that because they stored that more strongly at the time that they learned it? Or is it simply that they have a much stronger ability to retrieve information in their brain that has been stored? And we don't know that, but that would be a very important thing to find out. That means that we need to do neurobiological investigations of many kinds, and we have collaborations with a group in Italy that is now looking at the activation of the brain, and we found some regions of the brain that are differentially activated in these subjects who have this ability. But obviously, we're just at the beginning of this, and more research needs to be done. Now, here's the question that I think puzzles us all. As I said at the beginning of my little talk here, memory is critical. It is us. It is us. All animals have the ability, and the reason we have it is because we need it in order to survive. We have to glue together every minute experience that we have to create memories which enable our existence. If it's so important, why is this the ability that these subjects have so rare? Why is it that we've only been able to identify 200 or 300 people in the United States who have this very strong ability to remember the experiences that they've had? And we don't know why this is, but this is something I think that is challenging. One of the many challenging things about memory that I leave for all of you to consider and to investigate. Now, I end this with a plea for all of you to think more deeply about concepts of memory, how important memories are in your life, and how important it is to understanding the neural basis of memory. Not only because memory is just so intriguing and intellectually it's important to understand it, but also because when memories are lost, we lose our identity. People who suffer from memory loss, such as is seen in Alzheimer's disease, become no longer themselves. Who we are is built on the memories of our experiences. And when we lose those memories, we are no longer ourselves. And that's one of the reasons why the study of memory is so important. With that, I thank you very much for your attention.
Thank you so much for your lecture. That is so interesting. Thank you so much. So we have a few questions here. So the first question says, what causes repressed memories due to traumatic experiences?
Well, I question whether that happens. Most of the evidence that is available suggests that traumatic experiences don't depress memories. They create very strong memories, such as is seen in post-traumatic stress disorder. People who are exposed to enormous stresses don't complain that they don't have memories. They complain that these memories are driving them crazy. They have post-traumatic stress disorder, and that is a result of having excessive exposure to strong emotional arousal. I don't know of evidence that says strong experiences lead to weak memories.
Thank you. That makes a lot of sense. So Jill Price kept a journal diary that allowed you to check the accuracy of her memory. Was that common among other people with this exceptional memory? Could this improve autobiographical memory?
No, she was the only one who kept a diary of that kind. And it was fortunate that she did, because if she had not kept it, we probably wouldn't have investigated her very long. How would we know that she's telling us the truth? So that's what drove us to question her further. But we found in the course of our investigations that other people did very interesting things. One of our subjects allowed us to see her coat closet, and she had a very large number of shoes, with the shoes very carefully organized. She organized all of her dresses in terms of the date of purchase and the last day of wearing and so on. So we could verify that she remembered all of that, but also we could see the source of it by looking at the degree of organization. So we were able to, with each, not with each, but many of the subjects that we investigated, we were able to learn something individually about them, which would help give us more clues to understand the nature of their ability.
Great, thank you so much. And so according to the standard information processing model for memory, so sensory to short-term to long-term, isn't storage necessary for retrieval? Why is it that? It's either or. And do people with autobiographical memory often lack in some other characteristics, like people with savant syndrome?
Let me take the last question. No, we don't find that the people with a disability are lacking. It's not as though they have given up something in order to have this ability. But we do find that it is always associated with obsessive compulsiveness. That we do see. And so it's an add-on. They pay a price for having this ability because they now have to do something else, or at least it is associated with it. And that's the one thing that we do know. Now, the first part of the question, is there something I can amplify about that?
So the first part said, according to the standard information processing model for memory, so sensory to short-term to long-term, isn't storage necessary for retrieval?
Yes, storage is absolutely necessary for retrieval, but it doesn't mean that you're going to retrieve it if you've stored it. That is, just think of all the things that you've learned in the past that you're unable to remember at the present time. Now, the difference with these subjects is that for many of their personal experiences, they can retrieve them automatically, immediately, with so little difficulty. We can ask them, what were you doing on June 13th, 2004? And immediately they say, well, it was a Tuesday and I had a fight with my mother that day. And then I went for a walk and then it was school in the afternoon. And they describe it just as though it was yesterday. So the way I look at it is that for these people, most of their memories, even their long past memories, are like our memories of yesterday.
Great, thank you very much. And there's one last question here. So what are your thoughts on the topic of genetic memory?
Of genetic memory, in what sense? Can that subject amplify it?
One second. It takes a while for them to catch up. So 1 second. I'm going to ask what they mean. Maybe how memory is like if you can inherit it, maybe like if there's any relation of memory to your specific genetics.
I don't know of inherited memories, inherited abilities. I just don't know. I don't have a response to that question.
Okay, great. Thank you very much. I think that was the last question.
Thank you very much for organizing this. It's a very,
thank you very much.
Thank you.
Thank you so much for attending. Thank you very much. So our last presenter today is Professor Stephanie Rogers from Fordham University. 1 second, I'm going to put you out. Thank you.
Hi, everyone.
Hello. Great, I can hear you. Perfect.
Okay,
thank you.
Perfect. Okay, so before we get started, I just wanted to introduce myself very quickly. I am an adjunct professor at Fordham University, but I'm also the producer of a live show here in New York City. So for those of you who are interested in science, but not really sure you want to go the academic route, or you want to explore other options, there's plenty for you guys to do out here. that isn't just research. So my show, we actually do performance art to teach people about neurological disorders. So yeah, if you guys ever have any questions, you can put that in the chat about both that aspect of science or questions about the PowerPoint we're going to do. So this is probably, for those of you who have been tuning in the whole time, a lot of this is going to be a review, but this is just sort of a summary about mental health and sort of an overview of how all these different things kind of fit together. And then we'll talk at the end about some strategies you can use to help your mental health, especially with this global pandemic, where you are probably socially isolating. That is definitely a trigger for mental health issues. Okay, so one of the major problems, I'm sure you all know, about mental health is that it's super stigmatized, right? So anytime you tell someone like, I'm really struggling with this, you might get an answer of like, well, just get through it, or like, oh yeah, I've been through that, you know, you just gotta tough it out. You would never say that to anyone going through a cancer treatment, right? Like if somebody was like, oh, I'm really nauseated from my chemo, you wouldn't be like, oh, well, that's just life, you gotta deal with it. And since mental health is actually all based in biology, this is very hurtful and also very counterproductive to talk about mental health like this. So we're going to talk about mental health for what it really is, which is a biological process in your brain. So to start off, you guys can leave comments if you want. I can't really see them because my YouTube stream is not working, but what do we use our brain for? So Cynthia, can you read out any comments for me? Like in the most basic thing, what do we use our brains for?
I'm going to wait for the chat to catch up.
Okay. No wrong answers here, even if you think it's so obvious and silly.
Yes, I typed the question into the chat too.
Okay. You may feel silly answering it, right? Because the answer is everything.
So someone said to plan ahead.
Yep, that's exactly right. What else?
Decision making.
Decision making, yep. Really, it's everything, right? Your 5 senses, touching, hearing, seeing, feeling, tasting, that's all centered in the brain. Thinking, of course. Feelings and emotions. Learning, which hopefully we're doing today. Memory, right? All of these things are centered in our brain.
Yeah, we have more responses here. Sorry. So
Yeah.
some people said, so our brains control our basic life functions to keep us alive, problem solving, sending signals to other parts of our body, to solve problems, survival, and to be happy, and to think or to stop thinking.
Yeah, that's right. You guys hit all of those points. So we're really using our brain at any given time for a multitude of different purposes. And so when we think about the brain processes, you can kind of break it down into one kind of oversimplified process. And this is all that our brain does. It's that our brain takes in information. So in this example, we'll say an external situation, right? Like you're hiking in the woods and you smell something really bad. So your brain takes in that information, right? Through receptors in the nose, it's going to relay that signal to the brain. Then your brain processes that information, right? And that information we'll call a stimulus. And then the brain changes its behavior. So in the case of the skunk, the behavior is going to be that you run in the other direction, right? But this process can be applied to our mental health as well, right? Like if you're dating someone for 3 years and they break up with you, guess what? Your brain takes in that information, right? And it processes it. And when it processes it, the behavior change will be, I'm feeling sad, or I'm feeling down, or I'm feeling angry. So you can kind of simplify what our brain does by this process of taking in information or stimuli and responding and processing it to see, what does this mean? And then changing its behavior in some way. And so in the case of mental health, the way that these behaviors change in response to a stimulus is through the chemical messages that are carried in the brain. So for each neuron, right, these neurons talk to other neurons or these other brain cells. And the way they talk to them are through chemicals called neurotransmitters. So you can think of neurotransmitters as the words of the brain. So if my partner breaks up with me and I'm feeling sad, right, that signal is being carried through these neurotransmitters. And so there are three major neurotransmitters involved in mood. Now there's a ton more, and we're not going to talk about all of the other ones involved, but these are the three major players. We've got norepinephrine, which is involved in energy, alertness, concentration, right? When you're really involved with something, you're really concentrating on it, and you're really alert, that's your norepinephrine. You have serotonin. This is involved in like memories, obsessions, compulsions. And then you have your dopamine. And your dopamine is this pleasure, this happiness feeling. It's involved in reward and motivation, right? Like if you ask your crush out and they say yes, and that really great feeling you get, or you ace a really hard test, that rush you get is dopamine. And so you have these three neurotransmitters, and they're each responsible for their own sort of aspects of your mood and personality, but they also kind of intermingle, right? So if you have dopamine and serotonin, you'll get things like sex drive or aggression or appetite. Dopamine and norepinephrine is, again, types of attention, right? You're not going to pay attention to something if you don't get something out of it, right? Like no one's just going to sit and watch something if they don't learn or if it doesn't offer some kind of reward to them personally. And so you have these neurotransmitters that are doing the talking, right? And we already know they're involved in mood. And so the kind of tricky thing with these three neurotransmitters is that you have to have a balance of their levels in terms of like their raw levels. So if you're high or low in dopamine compared to your baseline, but because they interact, you also have this complex balance of ratios to one another, right? If your dopamine levels drop and so do your serotonin, but they maintain the same ratio of dopamine to serotonin, you're going to have a different effect on your mood than, let's say, dopamine dropping alone and messing with that ratio as well. So it's a really complicated three-tiered balance of these three neurotransmitters. And of course, why would the complexity stop there, right? This is the brain, so of course everything has to be complicated. So on top of these three neurotransmitters, you also have functional groups in the brain, right? You heard all about this today. We've got different lobes of the brain, and each lobe of the brain is involved in something. So your frontal lobe, anyone remember what that is used for? It's going to be your cognitive skills, emotional skills, problem solving. The big one is your judgment center, right? Your frontal lobe is often affected with things like substance use and anything that involves like judgments. So a lot of disorders where people are having erratic behavior, that is based in the frontal lobe. You'll have your occipital lobe, which is vision. You have parietal, which is sensation. And then you have your temporal lobe. And this is where your hearing, your memory processing, and fear. So your big players that we're going to talk about are these temporal lobe and frontal lobes. So again, we've got those neurotransmitter levels, and now we've got these functional arrangements, because these functional arrangements can change. And you can kind of already get a sense of that, because if there's a certain part of your brain that deals with fear, right? Anxiety is a fear-based disorder. So your fear kind of location, if you will, in the brain is the region called the amygdala, right? And your hippocampus is the sort of location for short-term memory, as well as spatial navigation. So you can kind of see here now, so if you have this fear center and you have this memory center, what do you think is going to happen if these two centers really start talking to each other, right? So if their neurotransmitters between these two regions is strengthening how much they talk to each other, you're going to see that you're going to have a lot of memory associated fear, right? If you encounter a certain location, a certain space, a certain circumstance that reminds you of something scary, you're going to have a fear response. And if that sounds like PTSD, post-traumatic stress disorder, guess what? That's basically the basis of PTSD. Of course, we involve the frontal lobe as well, because the frontal lobe has that long-term memory storage, as well as being that judgment center, right? Of that sort of inability to say, hey, the context I'm in right now is not the same that it was when I experienced trauma. Okay? And since post-traumatic stress disorder is a disorder caused by experiencing trauma, and then the result is increased anxiety, sleeplessness, having nightmares. So you can already see just by talking about connectivity or how much different brain regions talk to each other, we're already dissecting the circuits, the biology of mental health. Okay, so we still don't fully understand every exact mechanism, particularly in humans. And I sort of pose this question as to why, right? Why, with all of the advancement in science, do we not have better treatments for mental health disorders, right? Why are we still relying on the same medications we have been for years to deal with all types of anxiety disorders, right? You'll usually be put on the same type of medication, regardless of what type of anxiety you have. And the reason is it's hard. It's hard to understand this, right? In humans, we're limited by the technology. We can't probe, right? We can't put things deep in the brain of someone who's not sick. So we have to rely on studies that do this imaging, right? We've talked about that today. But that can only take us so far, right? That's only going to show us what regions of the brain are consuming more energy, that are likely more active. And so there's been a real need for looking deeper. And one of the ways we can look deeper is by using animal models. But you also have to consider that animals aren't people, right? You can't ask a rat, how are you feeling today? And the rat's not going to be like, yeah, you know, I have a pit in my stomach and I really don't want to eat my Fruit Loops, because FYI, rats love Fruit Loops. I really don't want to eat my Fruit Loops because, man, my stomach's really bothering me and I don't know why, but I'm antsy, right? So we're basically limited in what kind of things we can measure in animal models and what kind of things we can measure in humans. So this is why we may not be advancing as quickly as people would like us to, right? The way the general public thinks that we should be advancing. But what we do know is in anxiety disorders, which is a class of disorders that are characterized by this worrying, by this fear, this dread, this sense of impending doom, we have seen that they have overactive amygdalas. And that totally makes sense, right? Knowing that the amygdala is our center of fear, of course, it's going to be at the center of a fear-based mood. We'll have change in prefrontal cortex activity, right? So this is your judgment again. So let's say you're super stressed out about a test, right? Oh my gosh, if I fail this test, everything is done. So in the long run, right, not doing well on one test is not going to completely destroy your entire life and everything that you hold dear. But in the short term, you place a higher priority. You judge that this one exam is the be all end all, right? And so then you're saying, no, it is going to make or break me, when that might not necessarily make or break your life. So amygdala, prefrontal cortex activity, you see increased release of cortisol, that's your stress hormone, as well as neuroepinephrine. If you guys have ever been anxious, you know you're sitting there and you feel like very high energy and you might shake a little. You might develop like a nervous habit, they call it, like pick at your skin or play with your hair or do something kind of repetitive. And what that's actually doing is that's your neuroepinephrine. You have so much energy and you need to dispel that because anxiety is a high energy state. You'll also see that you don't get enough of the neurotransmitter serotonin, right? So again, we see these changes in the neurotransmitters, so increase of neuroepinephrine, decrease of serotonin, but also a change in which regions of the brain are paying attention to each other. And so the result of all of this is anxiety, which is more than just worried, right? A lot of people say worried, but they don't realize what this encompasses. Anxiety doesn't always feel like anxiety. You can sweat a lot. You can second guess yourself. Muscle tension is a big one. If you ever realize that like you're clenching your jaw or you're holding your shoulders very tight, or when you breathe in and let go that you're really relaxing your muscles, that's a manifestation of anxiety. Chest pain, right? A lot of quote unquote anxiety attacks, or like when someone feels overwhelmed by their anxiety, it'll feel like chest pain. Overthinking, increased heart rate, sleepless nights, or you may feel fatigued, right? This depends on the ratio change in your particular case of anxiety. Okay. And then on the flip side, you have depressive disorders, right? And so for depression, it's kind of in the name, where you see that overall brain activity is reduced. So what kind of symptoms would you expect with this? Well, you're having decreased activity all over your brain, right? So maybe your hippocampus isn't working at optimum, so you're not going to remember things as well. Your prefrontal cortex is going to not be functioning at optimum, and you're going to be missing quite a bit of dopamine, right? So if you're depressed, something that might normally make you really happy isn't going to make you happy. It's not going to give you that feeling because your dopamine levels are lower than they usually are. So when you do finally ask out your date and they do say yes, the dopamine rush you get, that only gets you back to normal because you're starting so low. Causes for both depression and anxiety seem to be genetic. We do see trends in families. If families have a lot of people with anxiety disorders, there's a higher likelihood that the next generation or their kids will have an anxiety disorder. We see the same of depression. Environmental, for sure. Included in environmental, so these are things like external stimulus, right? So what kind of home did you grow up in? What kind of experiences have you had? You experienced trauma, right? Your brain is constantly taking in these stimuli and changing its activity and changing its behavior. Remember from like the first slide? So any event, any situation can change the balance in your brain. Hormonal as well. So you can see hormonal changes like stress, also associated with menstrual cycles, testosterone as well. And then again, of course, situational. So anything can affect your mental health. Substance use, situations, environment. There's some evidence now pointing to diet. Diet can change or help affect your mental health. And so I want to point out with depression too, just like anxiety, it's not always the stereotypical symptoms, right? So anxiety, you might think somebody is very hyper or very nervous all the time. It may not always manifest that way. Remember, we talked about sweating or feeling pain in your chest or muscle tension. The same can be said of depression. So the stereotypical depression symptoms are excessive sleepiness and fatigue, excessive hunger, or loss of appetite. Again, this depends on your individual change in the ratios. Excessive crying, social isolation, and thoughts of completing suicide. So this paints a picture of somebody that doesn't want to talk to you, is always sleeping, but again, that isn't always what this looks like. So a lot of people with depression will do something called putting on their best face, putting their best face forward, right? They're sort of struggling and they think that this is my depression, this is my struggle. I don't want to burden anybody with what I'm going through, right? Or a million different reasons why they don't want to express what they're going through. And so they'll put on this face where they seem happy, they seem engaged, but if you know them very well, you can notice subtle things in their language choices, if they start changing a little bit their habits. So if somebody loved bowling and all of a sudden they're like, I don't know, maybe not, maybe let's just stay home and watch a movie. If they're doing that consistently, right, you may want to talk to them about, hey, what's going on? And so this brings me to my next point is, what can you do about it, right? First of all, if you suspect that one of your friends is having depression or thinking of completing suicide, it is important to be open and honest. Say, hey, listen, I noticed that you seem to be going through some stuff. You're losing interest in hanging out with me. You don't really want to hang out with anybody. I just want to know, are you okay? I'm here to listen. If you do suspect suicide, say it. Say, I'm worried you might be considering suicide. Most important thing though is never, ever talk to them judgmentally. You are not the judge, jury, and executioner, right? It is not your place to say suicide is bad. It's your place to say, if you're struggling, you should really look for help. If you need anything, I'm here for you. If you suspect it's going to happen soon, then you can call hotlines or you can call 911, depending on how imminent that threat is. So have an open conversation. And again, listen. You're not there to judge. You're not there to say, well, that's not so bad. Don't even say those words. Say, I'm here. This is hard for you, I know. I can't imagine what you must be going through. If I can help, tell me how I can help. Right? Your goal is to be an active listener. Your goal is to not provide judgment, but provide support for them to get the help they need. So with that being said, what are some of the things you can do to help you get through mental health crises? There's quite a few things listed here. Some of them are for more mild cases. Some of them are great for sort of stopping a cycle. And so I'll talk about each one. Deep breathing techniques. This is especially good for anxiety and high energy states because you can actually start hyperventilating where you're breathing very shallowly, like, right? And you don't always notice you're doing this. So take a deep breath and just regulate your breathing. Make sure your breathing gets all the oxygen you need, right? And that helps you because with that burst of oxygen, guess where that oxygen's gonna go? It's gonna go feed your brain. Okay? So deep breathing techniques can help. They're also very calming. We've seen through preliminary studies with EEGs that deep breathing and meditation can actually change your EEG. That's the measure of the electrical activity in your brain, right? We actually see that deep breathing and meditation can change some of the activity in your brain. Another one I really love are the mental health help kits. So a help kit is basically something that you turn to when you are cycling, right? You're in a cycle of thoughts. Oh my gosh, this pandemic's so bad. I'm not going to get a job. I was supposed to graduate. I was supposed to go to college. I don't know what I'm going to do. A mental health help kit helps you stop the cycle. And the way it does this is that you put something for each of your 5 senses. So sight, taste, smell, touch, and sound. Put one thing for each of that is calming for you, but that you don't use every day. That's important. If you use this object every day, it's not going to help you. You need something that is a really strong signal that you don't use every day. And the reason for this is because your senses are really good at overriding the information in your brain, right? We actually see this in some patients. It's been anecdotal mostly, but we see reports in patients with epilepsy that some kind of stimulus, right, some kind of loud sound might actually help them to get through the seizure. So a lot of this is sort of anecdotal, but people say that it works for them. You can try it and see if it works for you as well, because it could. And so, you know, things for touch would be something like slime or Play-Doh or a squishy brain. For sound, make a little card of your favorite playlist that's calming. It can be classical music. Nothing that pumps you up, right? Because if you're using this to get out of sort of an anxiety state, you don't want to like listen to hip hop and be like, yeah, I'm ready to go. So calming music. For smell, right? Your sense of smell is really linked to your memories. And so put a scent in there, whether it's a candle, a perfume, an incense stick, something that either reminds you of a calming time in your life or that the smell itself is calming. And so when you're cycling, you can take out this object and smell it. And again, you're kind of using your senses to override that. So now you're focusing on the calming smell or the feel of the slime in your hands or the sound of the music instead of concentrating on the anxious thoughts. Meditation, we kind of went over. Again, this is similar to deep breathing. It's hard, right? Like it's super hard to stop thinking. And that's basically what meditation is asking you to do. It's asking you to just let your thoughts go, acknowledge that you're having the thought, and then say that's okay and let it go, right? It's really effective. And so this is important because you can develop the skill, right? You're not going to be good at it the first time you do it. So this is something that you're building in the long term, right? You learn how to meditate, and each time you meditate, you'll get a little better and better at releasing those anxious or depressed thoughts. And so if you do try meditation and it doesn't work the first few times for you, don't panic. Exercise. So exercise releases endorphins, the kind of feel-good chemicals in your brain. Healthy, balanced diet. Again, we've seen this over and over, how what you eat and the vitamins and minerals you take in can have a huge impact on your health in general. Brain health as well as physical health. Limit caffeine intake. This is a big one if you are high anxiety. A lot of people will use caffeine to sort of get them through the day. So they may feel tired because, again, anxiety is a high energy state. You may wake up feeling tired. But limit your caffeine intake, right? You're already in this high energy state. You don't want to exacerbate it. And last, but certainly not least, and definitely the most important, seek help. When you get a cut, you put a Band-Aid on it. When you have strep throat, you go to the doctor, right? You go and say, hey, I might need some antibiotics. If you have the flu, you stay home. If the doctor says it is viral, then you don't need medication, but you need to stay home. But the important part is you're talking to a professional, right? Mental health is the same thing. It is health. It is biologically based. So if you are experiencing symptoms of anxiety or depression, talk to a therapist. It's, going to therapy should be no more stigmatized than going to the doctor when you don't feel well. It's just this doctor specializes in mental health, whereas, your primary care physician is specializing in sort of, the more kind of pathogen-based health. It's also important to note therapy is very personal. And so not every therapist is going to work for you. So if you go to a therapist and you come out of the session, you're like, I hate this person. They just don't get me. That's okay. Don't give up on therapy though, right? It's about finding the right fit. So just say, you know what, this one didn't work, but I'm sure there's somebody out there who can help me. And so keep looking until you find a therapist that works for you. And so before we close out this fantastic sort of symposium and conference today, I just wanted to leave you with a few thoughts about why so many people don't seek help. So in the United States, a couple years ago, they were saying that 63% of people did not seek help in a survey that the NINDS sent out. 63%. 63% of people are suffering and are not seeking the help they need. Why? Right? And I'm sure the values change based on cultural factors as well. So there's a lot of different reasons about this, right? If you live in a place where you need insurance, what if you don't have insurance? In the United States, it's very difficult to get insurance that covers mental health. So that means if you don't have good insurance and they don't cover it, well, if you want mental health help, you got to be in the upper socioeconomic statuses, right? What happens to the people who can't afford the rate to see a therapist? And it's especially those people who don't have access to good insurance either. So it's like a double-edged sword there, right? Or a double whammy. You're hitting these people twice. So insufficient funds for treatment, lack of insurance, unemployment, especially now in the era of COVID. Everybody's losing their jobs. And on top of that, we're in the middle of a global trauma. How do you seek help? Stigma and discrimination, right? People still don't want to, quote unquote, admit they need help. There's no shame in it, right? I would never feel ashamed for going to the doctor to say, hey, my throat hurts. Do you think I could have strep throat? I would never feel shame for saying, hey, I'm really struggling right now. I need to talk to a therapist. The way we talk about mental health is what's going to be what changes the stigma. If we are open about it and we talk about it and we say, hey, I'm really anxious today, I need to talk to my therapist. If you can say that, you will empower the people around you to say it as well. So don't shy away from conversations about mental health. Time pressure, again, this is something for, if you are an hourly worker, right? Most therapists also work 9 to 5. So when are you supposed to see a therapist? You also have patient factors or personal factors, right? So this is like your cultural background, your psychological defenses. This means that the therapist is not a good fit for you, right? If you just really don't jive with your first therapist, you may be sort of discouraged from pursuing therapy, thinking that all therapists are going to be like this. You also have the clinician factors, right? So this deals with if a therapist is not certified in treating, or I shouldn't say certified, if a therapist is not specialized in treating your specific mental health concerns, right? Then it's going to be a terrible experience for you. If you are a person with bipolar And the therapist that you go to really only deals with, PTSD, post-traumatic stress disorder. You're not going to have a good experience. So it's all about finding personalized care and not being discouraged through stigma, but also the access to that care, making sure that people can see a therapist and it won't bankrupt them. And so if we can sort of create policies about these things, taking care of these things in terms of the insurance and the affordability aspect of it, as well as having open and honest conversations about our mental health, then we can really change the conversation that society is having about our mental health. Okay, so that was all I had for you guys.
Thank you so much for the lecture. I think us as teenagers can really relate to this topic because nowadays it's a really big problem. Thank you so much. So looking at questions, so does different forms and types of depression come with their own distinguishing symptoms?
Yes. And so this is a hard thing to answer generally because it could be like situational depression where a very clear event happens and that causes the depression. Or you can have somebody who is born with, they call it like low mood disorder, right? And so the person was just born or has developed in a way that they are really low on those three major neurotransmitters. And so depending on, what sort of is the kind of root cause of the depression is really going to dictate not so much the medication, because we really only have one medication for all mental health disorders, which I can talk about that if you want. It's really going to depend on what the therapy will look like.
Great, thank you so much. And on epilepsy, what kind of stimuli besides a loud noise can help through a seizure?
So a lot of this is kind of anecdotal, but there have been some reports of touch. So if somebody who is very close to the person who is having a seizure sort of rubs their back, it can help them pull through the seizure or at least be comforted. So my sister has epilepsy actually, and she's mostly unconscious, meaning that she's lost awareness. She's not like laying on the floor, but her consciousness is altered. And she'll tell us like, I could feel you guys in my seizure, so I wasn't as scared, but like I didn't know it was you. I just knew that somebody was there for me. And so it really depends on the type of epilepsy, but yeah, sounds, touch, never taste, because you should never put anything in the mouth of someone who's having a seizure.
Thank you, understood, that makes sense. And so what sort of foods have been found to help your mood?
So fruits and veggies. There was some kind of truth behind the Popeye, like always eat your spinach. Anything that is sort of rich in like vitamins and minerals. So fatty foods aren't good for you for a million different reasons. So, a lot of the research with this, like, is red meat good or bad? There are trends, but it changes a lot. So I would just say right now, definitely fruits and vegetables and like a healthy, balanced diet.
Great, thank you. And so yes, you mentioned that diet can affect mood and mental health. I read that gut bacteria affect our mood. Is there any reliable literature for the general public?
For the general public. So I know some scientific articles, but they're very, very dense. I'm not sure if anybody translated them into something that like you don't need a PhD in microbiology to read. I can look into that and email you or email Cynthia, and then she can send it out. But as a brief answer, we've seen that it actually changes the levels of neurotransmitters. So that's part of the reason why the ketogenic diet works for epilepsy as well. What you eat can change your gut bacteria, and that changes the neurotransmitters in your brain.
Great, thank you. And so, Yeah, so this is kind of the same question. So does mood change caused by eating fast food, which is a lack of valuable nutrients? So yes, you said that, for like nutritionist.
Yeah, so
Or-
I hesitate to say cause, but it can exacerbate.
Okay. Or is the negative effect due to additives like colors and taste enhancers, etc.?
To be honest, I'm not sure about the colors and the taste additives. I'd have to look into that. But it's usually like fatty, greasy foods. That's been what I've read the most. But you know, that is not my area of expertise. So I will definitely look into that.
That makes sense. Great, thank you. And any literature that you can suggest for the general public around like your main topic, like for these disorders?
For each disorder?
Like I assume like in general for the disorders and like mental health probably.
Yeah, so there's several resources. Frontiers for Young Minds, they target their audiences for like middle school, but you know, don't worry about that. It's really a fun type of article. They have a lot of stuff about mental health. I also did some summaries for a group called Neuroscience, KNOW Science. There's a lot of like people on Instagram and Twitter who talk about this kind of stuff as well. But if you guys want, I can compile like a list of things and then have, because I see this question keeps coming up, and I can have that sent out to you all if you want.
Perfect. Yeah, and then I'll link that to this video. Great, thank you.
Yeah.
And the next question says, how do you treat a family member with mental health that causes them to be abusive?
This is a really good question. First and foremost, I would say you need to take care of yourself. So if you have a family member who has mental health, I would 100% recommend you getting a therapist. And especially you seeing that therapist alone, right? Sometimes if it's like a parent, you know, parents, a lot of people have borderline personality disorder parents. And so that can be tough, right? To like get your own therapist that you see by yourself, but it is definitely worth it because your therapist will be able to give you insights onto your family members' mental health and then how you can respond, right? And then if you need to scream or cry or just sit in silence and just stare into the abyss, you can do that with your therapist. So that would be the first thing I would recommend is you have to take care of yourself. And in doing that, you should get a therapist and then they will guide you so that if it's bad enough that you need to get away from that person, then you can make that decision knowing that you were fully informed from a mental health professional.
Great, thank you. And how can you tell if you are having an anxiety or panic attack or if you are just stressed?
That's a great question because they feel very similar and their mechanisms are very similar. So the way I kind of think about it is if I'm stressed about a lot of things at any given time, that's probably anxiety, right? My anxiety is making me stressed. So if you notice like you have chronic stress or that you're stressed about everything and that, you know, something that may not necessarily have the same importance to someone else, you know, like again, acing a test, right? Someone else may not care and someone else may, but you notice that you are putting so much emphasis on this and you're doing it consistently, that's when you might want to talk to a therapist. Because even though we call it like slightly different things, the mechanisms are so similar that a therapist can also help you get through stress as well. The answer is always go to therapy.
Great, thank you so much. I think that it is it for questions, as far as I can see. Yeah, so thank you so much for the lecture. I really enjoyed it. Thank you so much. And thank you for accepting my invitation. Thank you so much.
Thanks.
Thank you. So just as a closing note here, so once again, thank you to everyone who attended. Thank you all to lecturers and professors who attended as well. I'm sure we all learned a lot. And so I will be leaving this conference up on YouTube, and I will be posting the link on my blog, and I will probably be sending the link out to emails as well. So anyone who missed maybe a part of this or could not watch it for whatever reason can rewatch it. And I have gotten a few questions about whether I will be holding an event like this again, because there seem to be people interested. So if people are interested, if you have any other recommendations or ideas about what topics you want to hear about, then feel free to email me and I will try to put together something. So thank you to everyone. And I just found one last question to you here. So do eating disorders stem from the same parts of the brain as depression and anxiety?
Oh, yeah. So eating disorders are classified as a mental health issue. And so like eating disorders are interesting because the thing that ends up being the reason or the cause of mortality is nutrition problems, but it is entirely mental health. And so when you talk to people with eating disorders, there was a really great book, I'm blanking on the name right now, but it was basically this book that talked to people who have eating disorders. And a lot of people will report these other reasons for developing an eating disorder that has nothing to do with, at first, that sort of body dysmorphia of like, oh, I'm so fat. What it stems from, a lot of people will say, is like a need to have control because the rest of their life is out of control. It's a means of expressing how much they're hurting inside, right? Because we still have this feeling of like, oh, you look fine. You don't look like you have depression, right? Well, what does depression look like? So people will develop these habits that say, look how much I'm hurting. I weigh 70 pounds. Do you recognize my pain yet? So there are a lot of underlying factors like this. So yes, anxiety, depression, these same kind of neurotransmitters that are involved in what we talked about today are 100% involved in eating disorders.
Thank you. And how can you help someone with an eating disorder close to you?
That's a great question. So again, you always want to encourage therapy, but the way you can do it is a lot of people with eating disorders won't want to eat in a big group. They might be more sort of amenable to eating if it's just with you, right? And so again, open conversation. Either if you already know they have the eating disorder, you can say, hey, listen, what do you need from me? How can I be supportive of you? Ask them, right? They know better. If you suspect it, you can say, hey, I noticed like you always go to the bathroom after we eat. I'm worried about you. Do you think you might be having an eating disorder? And then you let them tell you what they need. And again, always encourage, without being judgmental, therapy, right? Oh my gosh, this sounds so difficult. You should really talk to a therapist. Have you considered that? I went to one and I felt so much better. Really destigmatize that. And again, the worst thing you can do is isolation. So if they say, I don't want to go out to dinner, say, you know what? I don't either. Why don't you and I have dinner at home and then we'll meet people for the movie afterwards, right? Be there, be present. If you follow those kind of guidelines, that should get you through helping any person going through any mental health disorder.
Great, thank you very much. I think now that was it for questions. So thank you very much again. Thank you to everyone who attended and watched this. If you have any questions to me, then just write to me per email. And I think you can also contact the professors, I assume. If you have more questions about the books, I will probably post the book links that I've been getting from the professors somewhere. So yeah, thank you to everyone who attended. Thank you very much to you as well. And I guess I hope everyone has a very nice day. Thank you so much.
Thanks.
Thank you. Bye.
Stay healthy.
yeah, everyone stay healthy. Thank you for the comments and thank you for the feedback. Thank you so much.